That's all I had to say. Okay.
Okay, thank you. Yeah, so thanks for the invitation to present. Yeah, this was a topic that I submitted for the Distinguished Lecturer Programme, I think last year. So really what I'm trying to do is explain, all of the different dimensions that go into the drilling process, really to try and highlight a lot of the interconnections between the various different groups. And once you understand the interconnections and the implications or cause and effect within the system, this really then starts to lead to breaking down, the cross-disciplinary barriers, because people are less siloed. They understand kind of cause and effect with their decisions and how that impacts the larger drilling process. So it shares, information or kind of experiences, we've had along the way in dealing with issues through SPE. And then also a proprietary workflow that Halliburton developed, which was cross-discipline workflow, which I'll talk about, which is really an attempt to link together all of the capabilities and people involved in drilling a hole in the rock in the right place and doing it so safely. So, with this type of format, I'm quite happy to, stop and answer questions along the way rather than waiting to the end. So, I'd prefer much more of a discussion as we go along than me just killing you with PowerPoint for 90 minutes. Yeah. So let's get started. So the first I'd like to share is a quote from Sove Arup. Engineering problems are underdefined. There are many solutions, good, bad, and indifferent, but the real art of engineering is to arrive at that good solution. So the first challenge is for us to understand what makes a good solution. What is good for us, what is bad for us. And more challenging is not accepting indifferent solutions. We can have many wells that are drilled, which you would term successfully, which means nothing goes wrong, but you're not necessarily tuning performance or really trying to push the envelope of what is possible because you can accept the indifferent solution as part of the process. So we really need to look at, how we develop a good solution. And it really is an art, and it involves a lot of different knowledge, a lot of cross-discipline sharing, clear goals, clear targets, and a deep understanding of the engineering and behavior of the equipment and an understanding of the environment. So how do we go about establishing the good versus the bad versus the indifferent? And really, the goal that we have is to maximize reservoir production and deliver the wellbore safely and to the required quality. And then also do this as quickly as possible, but with the lowest practical cost. So some of these requirements are actually in opposition to each other. Extreme speed might lower quality, lower cost might reduce performance because things are done too cheaply. The wrong equipment is selected. Too cheap might also compromise safety. And then overall, we have to get the reservoir production, which for most wells is the purpose, get the hydrocarbons to surface, or if we're drilling injection wells, to be able to drive the fluids into the ground to drive the hydrocarbons out for production. So really, to do this, we've got to set clear goals, but then we also have to understand what the barriers are to superior performance. And the first one is really not accepting average performance or not accepting performance when nothing goes wrong, because in that case you're not really pushing the envelope of what's capable. And then optimization and tuning, is how many iterations through the system design do you have to achieve before you have that highest level of performance. So the first thing to look at is really defining, effective optimization criteria. So what are the performance measurements that we use or typically use within the industry? So historically, we can look at a range of wells or a range of areas and look at various different metrics that are used. But these are predominantly, time savings on the well. So did we drill it shorter, which is really trying to reduce operating expenditure. We can look at cost savings in total, which can be the operating expenditure reduction, but we can also have capex reductions. There's a project Halliburton worked on in Brunei, where we actually developed the ability to drill hook wells from a beach. So you drill down vertically and then basically drill a hook and finish the well at about 140 degrees of inclination. But in doing so, this allowed them to penetrate the reservoir from underneath and remove the need to place an offshore platform and drill extended reach wells into these reservoirs. So in optimizing the process there, it was a compromise, or the ability was, in looking at the problem, was really to remove the requirement to have an offshore platform and drill all the wells from onshore. But to do so, we had to both develop the ability to drill uphill and then also to run the production equipment uphill. So in that situation, one of the other challenges was that you had two high angle slopes, one as you drilled down the first part of the hook, and then one as you drilled up the second part of the hook, which was really a huge location for the accumulation of cuttings beds and cutting bed buildup. So the entire process and hole cleaning process had to be evaluated. So, the result of that well was that we reduced a massive amount of capex in, avoiding the development of an offshore production platform, and then put all of the production infrastructure just onshore, which made it a lot more accessible. But as a whole, really the industry, as our metrics, we're focusing on speed or we're focusing on cost. But I would argue that there's a lot of other metrics that come into play when we start dealing with quality and we start dealing with optimization. So this is a paper written a number of years ago by, I think, collaboration between Halliburton and BP, so SPE 98893. And really it was looking at the effect of wellbore construction cost and a wellbore quality scorecard, and looking at the general impact that improving that improving quality has on the overall well construction cost. So this looked at not only the AFE of days versus depth, where we look at cost versus time, the activity of analytics of the time breakdowns, looking at non-production time and what we call invisible lost time, which would be drilling efficiency. But it also introduced wellbore quality scorecards, where it measured and put metrics to the ease of drilling the well, but then also the ease of tripping and the ease of casing the well. So it wasn't a question of just drill the wellbore as fast as humanly possible. It was also making sure it was delivered with the sufficient quality so you can get the BHA and drilling equipment out of the hole and then run the casings or completions afterward. So one of the things that they learned was, that the very low quality wells obviously cost a fortune. And these become the train wrecks where once things start to go wrong, remedial actions are extremely expensive, extremely time consuming, and this really drives up the cost. And then the wells they examined, that as the quality increases, overall the wellbore construction costs come down. And then you reach a level where you have high quality or high to very high quality, which is at lowest cost. But then if you keep trying to push further to increase the quality of the well, basically you begin to add cost to the well by over-engineering it, putting in too many kind of unnecessary kind of safety, extra levels of safety that are probably not necessary, or extra levels of redundancy that are probably not necessary. So there was this sweet spot that they identified on their scorecard, somewhere between a 14 and a 16, that said, we have to deliver high quality, and in doing so, that will give the lowest level of wellbore construction costs. Don't go too low on the quality, because this drives up cost through failures or remediation efforts. But again, don't over-engineer on the other side. So really the first barrier, I can see to improving overall drilling performance is to change the KPIs to really measure or identify the reason for the resulting performance and focus on the root cause of how that performance was achieved, rather than looking at the results, which would be just cost and time reductions. Because unless you understand the reason for the improvements in quality, it's impossible to replicate it or tune it or make it better. So in looking at the different areas, we've proposed various KPIs that would affect production, the well time, and the well cost. And this is really maximizing the production. So the first area is the wellbore placement. To make sure that we can do this accurately, we can place it in the right level or right zone within the reservoir. make sure all the targets are hit, and maximize any production that's necessary. And this could be either geometric well placement, where we're following a predefined well plan or well plot, or this could be geological placement, where we're placing the well relative to the various different layers or rock properties within the formation. Wellbore quality is also important. I mean, not only does this affect our ability to drill and drill very long wells or extended reach wells, when it comes through to production, the quality will also affect the production rates, so that we don't have gas trapping on the top of the hole or slugging occurring, or different challenges in running completions equipment into the well. We also have to address the equipment mechanical efficiency and the reliability of all the drilling tools, because if we want the highest levels of performance, all of our equipment has to function in that environment correctly and be durable and resistant enough to last the entire well without failure, and deliver the high, or be able to cope with the high levels of mechanical loads that we'll place on the equipment whilst we're drilling the well. We also have to manage drilling dynamics. We're rotating a drill string, sometimes at very high speed. We've got large masses moving around downhole. We have frictional interactions between the BHA, the stabilizers against the wellbore, which will drive vibration. We also have excitation sources coming from the bit, where we have the bit-rock interaction, which will drive vibration throughout the system. So managing the dynamics and the drilling, time-based drilling behavior to minimize damaging vibrations, and also looking at the hydraulic system and the energy transfers throughout the system is hugely important. Drilling fluid and hydraulic system efficiency. This can put limiters on our ability to drill a well, both from the sense of hole cleaning, as well as providing power to downhole tools such as driving motors or turbines. Also, a lot of MWD systems and rotary steerable systems these days have downhole power generators, which are powered by turbines. So optimizing the flow rates for all of the downhole equipment is important, as well as balancing all of the system pressure drops, the hole cleaning, the ability to cool the bit face, move cuttings away from the bit face, and then remove cuttings from the wellbore, as well as managing the hydrostatic pressures and hydrodynamic pressures so that we don't swab or surge the well when we're moving the pipe. And then the final area is really real-time measurement, the quality and availability of the measurements. If we're trying to drive improvements in drilling performance, we really have to have comprehensive measurements of how the system is behaving. This is relatively easy at surface. We can instrument the drilling rig. We can acquire data at very high data rates. Downhole, the downhole systems, we can have a lot of instrumentation in the BHA, both from formation measurements and also drilling dynamics measurements. And we can process a lot of information downhole very rapidly, but one of the limiters to transferring that information is the bandwidth of either the mud pulse telemetry, electromagnetic telemetry, and more recently, we've seen the development of wired pipe to kind of increase that bandwidth. But the quality of the measurements is hugely important, that garbage in, garbage out with a lot of the assessments, and also the availability of that information is how timely can it be made available to the right people. So if you look at wellbore placement, there's almost an infinite number of ways to connect the surface hole to the target. And really what we're looking for from a trajectory is the most mechanically efficient well path that we can create for drilling the well, but also the placement of the well and the number of wells required to expose the reservoir and get the production we need. So this is an illustration just from a road cutting, that the project could have been developed by using, various different vertical wells, for production and injection, and space out vertical wells throughout the field. Or the suggestion is to drill one, lateral well horizontally all the way through the key formation. So we'll drill a long single well bore, but we should be able to achieve a similar level of production than would have been required for 5 or 6 wells. So understanding the wellbore exposure and also the trajectory requirements, the first step. And you can iterate backwards and forwards on the mechanical efficiency, the well path, the length of the well, how effectively we can hole clean, and also the mechanical torque and drag limits that come about because of that path. We also have to consider the temperature and the pressure of the environment because this places limits on our downhole equipment. Downhole electronics will only function up to certain temperature ranges. So within the MWD systems and rotary steerable systems, we typically have a solar rating and then now ultra high temperature ratings for these tools. So you're looking at 150 degrees C, all the way up to 175 degrees C. Once you start going past that, it really becomes very, very challenging for the electronics to survive. Also pressure limitations with deep water wells. We could be looking at 30, 35 PSI hydrostatic pressures. So again, all of the measurements and electronics have to be packaged to withstand those extreme temperature and pressure ranges. We have positional uncertainty that comes into wellbore placement. So with surveying and survey management, there's always an accumulated error. Every time you take a survey and use that measurement to calculate the position of the wellbore, you accumulate errors. And this is a function not only of the tools that you run, bias is inherent within those measurement devices. You can also have environmental effects around you, so gravitational impacts, magnetic impacts from the rock. And then for magnetic surveying, you have the influence of solar flares on the Earth's magnetic field. And in that case, you can have azimuthal swings just because of changes or influences on the Earth's magnetic field because of the kind of solar radiation. So being able to reduce the positional uncertainty and to be able to increase the accuracy of where we're placing the well also has a huge impact on performance and ultimately the production. We have to consider wellbore stability and also the reservoir production. So typically the direction we want to place the well for maximized production is the opposite direction we'd like the well to drill the well for maximum stability. And this is also going to depend upon the fault regime that you're in, whether you're in a normal fault regime, strike slip or reverse faulting regime, to understand where the maximum stresses are and also the stress contrasts across the wellbore. So again, there might be conflicting interests or conflicting requirements to place the well in a better direction to improve production, or if we're fracking the well to make it easier to create fractures along that wellbore. But this would narrow the mud window for drilling, making that margin tighter.
Jez, we have a question, and since you encourage having those through the
Oh, sure, yeah, go ahead.
Unless Simon wants to do it. Thanks, Jez, really good. You mentioned real-time measurement. Real-time drilling centres have sometimes faced challenges to realise promised benefits in the area of cross-function collaboration. For example, SPE and HPM. What's your recent experience? Are real-time centres now enabling full collaboration?
I think they help enable collaboration, but it's not just having the data. You really have to have clear workflow processes where people understand how to use that information. You also need to understand in the decision-making process when people need that information to make a decision, or when, say, rig activity becomes critical, that you can actually react to it or mitigate the problem. So they're very much, I think, an enabling technology. But in of themselves, just capturing and displaying data is just the first step along the way. So it's really developing the knowledge and the internal processes within the centers to drive that collaboration. There's a very big difference between somebody throwing up a red flag and saying, we've seen a drilling problem, in my real-time center, look, here it is, to being able to look very quickly, analyze why it's happening. Maybe you can't get a root cause immediately, but you can look at the right corrective actions to mitigate the symptoms, which then drives on to having, very clear communication protocols and authority for action. So the center itself is, as I say, kind of facilitates that process, but you have to have those processes wrapped around it to make great value from it.
Simon, do you want to add anything?
Yeah, thanks. I agree thoroughly, and I think it's very difficult to get those workflows and processes agreed across different organizations, sometimes between operator and service company. But I agree that that's it. I think a lot of the problem with them is they've got a lot of idealistic overpromising some years back, And you're right, they really only deliver value if we've got the workflows. I just wanted to know what your experience is with centres recently. Have people got the hang of those workflows or not?
I think there's such a broad spectrum of centres that have been created. I mean, you see sort of rig manufacturers looking for real-time centres which are really monitoring the behaviour of the rig. I would say from a repair and maintenance and efficiency point of view. You know, you have centres being developed by the service companies which are about monitoring their equipment, the information, the data, and again, it's driven for quality.
Yeah.
And then you also see probably more operator-driven centres which are looking at the overall operation and trying to identify how to improve. So you still have that element of there's a safety net and another pair of eyes looking at it.
Yeah.
But I think the transformation that's happening and we're seeing at the moment is that it's less becoming a safety net as to be more the primary control center for the rig rather than it being the second pair of eyes behind the drilling. So I think there's a lot more focus on sort of I would say demanning rigs to move the expertise off the well site with the belief that if your centers are efficient, your knowledge collection is efficient, and you have automated systems backing you up, you can apply the knowledge of that expert to more than one rig at a time.
Yeah.
But it's a real tricky balance point to make sure that you're not overloading people with too much data.
Yeah.
And that you also have trust in the systems that are interpreting the data and coming up with intelligent answers.
Yeah.
And when you go down that path, it actually puts more burden on the experts to be able to validate the software output to say, is it correct or has it just done something strange that we're not aware of, you know?
Yeah, right.
Yeah.
Okay, thank you. Yeah, thanks.
Yeah, but there's lots of interesting challenges behind it, definitely. Yeah. Good. Okay, so you know, other aspects to consider around the metrics would be the optimum number of wells for the project or the production. You know, how best to place them. You know, how far can we drill from the wellhead, and also how to interleave them. You know, so some wells, such as you know, SAGD drilling in Canada, where steam-assisted gravity drainage. You know, we want to be 1 to 2 meters separation between the steam injection well and the production well, you know, to drive the heavy tar. You know, other wells, you're just drilling a big borehole into a reservoir that will produce, you know, some of the deep water wells, it's a single well bore. You know, so one well might get you all the production, but in another field, you need 20 wells to get the equivalent. So from the optimization criteria, you know, we need to know how many wells to drill, where to place them, what's the general uncertainty of the position of those wells, and temperature and pressure constraints, and then the reservoir exposure needs. When we start looking at wellbore quality, we've got very different scales mechanically at which we can influence the quality of the wellbore. So we have bit influences where we would see hole spiraling. This really is in the magnitude of feet. So you can generate a spiral within the wellbore, which is kind of a function of the distance between the bit face and the first stabilizer. And generally, this is when you don't sufficiently stabilize the bit with having the right gauge pad length or taper. So the bit can kind of oscillate in the hole and drill a spiral, which then cuts down the pass-through ID of the wellbore and the dimensions of equipment that can follow that spiral. You then have more at the BHA level where you're drilling. So this can be more influences on directional control. And especially when we have rotary steerable tools that can react very quickly by changing the inclination or the azimuth of the bit. You know, the driller, if it's manually controlled, can kind of go overboard with corrections. So you see either porpoising where the well goes up and down, or it can move laterally from side to side on an azimuth, and again, giving a lot of tortuosity, you know, from that behavior. A lot of the rotary steerable systems available now have what we call cruise control settings or automated drilling settings. And because you have, you know, very high-speed electronics within the tools, they can correct much more accurately, you know, the bit face and the side forces acting on the rotary steerable system, especially to drill straight lines or drill tangent sections. So again, what level of quality do we need? And then finally, the wellbore level, kind of the drill string level, this is how much tortuosity we put into the design itself, so where are we making the turns, the bills, the drops, could we do them sooner? Are we limited by formations where we can't build or drop easily? So we have to do more directional work later on in the wells. So you need to understand the scale of the tortuosity. We also have the kinematic relationships or force relationships going on as the bit interacts with the formation. BHA directional behavior is controlled by the stabilizer positioning, side forces that are occurring through gravity. It's effectively, a series of fulcrums that act to tilt the BHA and then have a resulting force at the bit itself. We can sort of increase or accentuate all these forces by putting bends into the system. So that, with a motor, we put a bent housing in, which makes it build or drop more. Rotary steerable tools, we control the amount of build or deflection of the bit. So this improves the behavior there. Bit rock interaction, how we design the bit itself to destroy the rock, what angle are we intersecting the rock, what formation types are we going through. You can see here some real interbedded formations where we've got sands and shales, probably some limestone streaks involved as well. So if we're running perpendicular to these formations, the bit will drill in one manner. But if we start to drill through these at an angle or higher angle, you have the bit face crossing two different layers at the same time. So you get very different torque demand on the bit face, which can lead to dynamic problems or oscillations, or we can get ledging or roof collapse. So there's dynamic issues there. So here's just some wireline logs. I think this is an FMI log taken. So this is a hole, the top 2, 3, just over here, are ones in a normal hole with no spiraling. What's interesting though is you can still see, some level, of oscillation in the wellbore position itself, just as the well's been drilled, but this is relatively smooth. Below this is an FMI image of a spiraled wellbore drilled with a motor. And you can see very clearly on the images how that spiral has occurred. And this is basically rotating the bent housing of the motor, so the bit's forced to drill kind of in an eccentric manner, and then again, we've got this influence between the face of the bit and the first stabilizer. So in the top hole and the top picture, you can see there's a larger pass-through ID of the equipment you can get through that diameter, but with the spiral that narrows down. So every stabilizer behind you in the BHA is going to get caught up. We also have potential for chemical failure of the wellbore. So this was a test showing, I think this is a water-based mud on a shale over time, and they could see the breakout and the enlargement on the test sample as it begins to break down. And then the picture above actually shows a production well that had been displaced to brine, so they could send a camera down the wellbore. And this shows kind of a whole collapse at the end, which is what they sent the camera down to investigate. But you can also see how rugged the wellbore is with these interbedded formations, and how the rock just breaks out as the wellbore is being drilled. So it's crucial that you really understand the environment that you're in, and then this then starts to link back to being able to modify the drilling assembly and also modifying the trajectory to maintain the stability. So mechanical efficiency and reliability, we need the equipment design to be effective in that environment. So designing the drill bits or under reamers, there's lots of advances in recent years in the strength of cutters, the types of cutters. We're starting to see hybrid bits coming out where we have both PDC and roller cone features on the same bit, so we can both shear and crush the rock. There's a lot of detailed work goes into designing these bits. A lot of different features that can influence the speed of penetration, the stability of the bit to manage vibration, and also the directional control. But unfortunately, the challenge is if you overemphasize one, the other two become a problem. So if you make a bit that drills very, very fast, you may increase the levels of vibration coming from that bit, and you'll also reduce the level of lateral or side cutting efficiency, so your directional control reduces. If you have a bit that's very good at side cutting, it's quite unstable, so again it can vibrate, and because your side cutting is greater, your forward penetration becomes lower, so it becomes a balance. And there are many features of the bit design that can be altered to balance these requirements. We also have complex tools downhole, motors, rotary steerable tools, MWD tools, LWD tools. So all of these have to be mechanically efficient. We have to transmit torque through the tools as we rotate the drill string. We have to flow mud through the center of the tools, so they have to resist the pressure differential between the inside and the outside of the drill string. With things like motors, we actually use the flow to drive the power section to rotate the bit and the lower bearing section. So in driving the bit, we have to transmit that force from the power section round the bend to the bit. So we have a transmission unit. So the transmission unit here not only has to take compressional forces because we're pumping on the power section and compressing the system, it also has to be able to transmit the rotary torque around the corner, so you can get wear on the top and the bottom of the transmission unit. Then we have to have a series of bearings below that, which not only have to take the load from the weight of the drill string above, we have to take the load from and we also have to resist the force from pumping, which basically, as you turn the pumps on, the whole of the internals of the motor are trying to force themselves through the bit. So the bearing pack has to resist those pressures. Once we put the bit onto bottom, we then take load from the drill string. So then also have to transmit the compressional load from the housing through the bearing pack down to the shaft and onto the bit. So all of these materials and configurations have to be balanced for the well that we're about to drill. We also have to look at the BHA component selection and configuration. Position of stabilization hugely affects the directional performance of the BHA. And to get directional performance, we have to bend the BHA. So in bending the BHA, we create stresses within the string itself. We need to do the torque and drag calculations. We need to lift the string in and out of the ground. So any load that we put onto the drill string, we have to be able to pick it up. And also transmit torque throughout the system as we rotate. And the higher the angle of well, the more drag that we get on the side of the hole, the more the friction increases, the more the torque increases, the more the demand comes to the bit. And as I mentioned, you have to look at the stress loading of all the components in the BHA. So this is showing a force model and the bending moments for each of the components, and it's a sensitivity analysis done on the dogleg severity. So this will give you a calculation to show the maximum limit that you could rotate the BHA around from a dogleg point of view before you start getting into the position of fatigue, accelerating the fatigue of the system, and then ultimately driving a failure. One of the things you can do, is to drill a high dogleg curve with a motor and then send a rotary steerable system after it through the curve and then drill a lateral with a much higher ROP. However, you have to be very, very careful about how much you can rotate that rotary steerable system in the curve before you start to generate fatigue and drive a failure into the system. So again, looking at performance, all of these factors have to be understood and balanced to be able to drill as efficiently as possible and maximize the energy transfer from surface down to the bit. When we look at the hole cleaning, not only does the trajectory come into play here, the hole angle itself, the cuttings transmission method is very different. In a horizontal well, you have saltation where the particles basically bounce along the bottom of the well bore. So in this section of the well, they're not really lifted up, they kind of bounce. Then we get into an area where you're coming up or building angle close to vertical. There's another transportation regime in here known as boycott flow, where it's a hybrid between it being fully suspended and flowing up the well bore and the saltation bouncing. And then once the whole angle gets closer to vertical, then all the particles have to be suspended in the drilling fluid to bring them out. So the rheology of the well, of the drilling fluid, needs to be balanced so that we can clean the hole effectively, but the fluid is not so viscous that we can't pump it. So this then balances out to how long we can, how far we can drill the well, what the surface limitations are of the rig. Obviously, as the hole angle changes, the position of the drill pipe in the wellbore changes. So in a vertical well, the assumption is the drill pipe's pretty much centralized, and you have a kind of constant flow velocity around the pipe. But in the higher angle and horizontal wells, the drill pipe sits on the bottom of the hole, and this really changes the flow profile and the velocities through the wellbore. So when the pipe sits on the bottom of the hole, we get cuttings build up around the pipe if it doesn't rotate. And the challenge is getting all of those cuttings into the high velocity area, so they're driven out of the hole. We have to manage the pressures in the wellbore, the ECD, circulating pressures, swab surge pressures, and then also be able to kind of remove or effectively move, all of the cuttings out of the wellbore with the level of, the correct fluid velocities to be able to manage that. This was actually a picture from a video that was done on some full-scale trials looking at sweep effectiveness, changing the angle of the wellbore. So this is a nice smooth perspex, nice smooth perspex tube. But in reality, you might be drilling through something like a collapsed hole where all the cuttings can get into the low side crevices and really provide traps. So if you're running into the hole, the BHA can slide over the top of these cuttings beds very easily. But when you pull out, you start to drag stabilizers into them, and then you get this kind of mechanical pack-offs where the materials push behind the BHA. And the very kind of rugose or rugged looking holes are much more challenging to trip through because lots more loose material can be trapped in there and then can be excavated as the BHA comes past. For a lot of drill bit designs and complex tool designs, there's a CFD analysis is done to look at flow areas and flow paths to make sure that we're effectively cleaning the face of the bit. Another thing they'll look for is, are there any dead spots or eddies, because we don't want eddies occurring around the bit itself, where you'll have if you begin to get the eddies and you get material in there, it'll start to erode holes in the bit. So making sure we have the right velocity, the right flow paths, the ability to clean the junk slot areas properly, and then also to transmit cuttings, past the BHA. So this is really, when the flow is on, but also there's a lot of consideration has to happen with no flow and cuttings beds within the wellbore where you're dragging the BHA past. So really the size and shape of the stabilizers, do you have a line of sight through the stabilizer? What are the angles on the blades on the back and the front? Can you drag like a bulldozer and have the cuttings move easily over that, or are they going to get into a tight spiral, cause a restriction, then cause a pack off? We also have the ability to measure downhole pressures, circulating densities, static densities, swab surge using PWD tools, pressure washed drilling tools. The best ones have an annular sensor and an internal sensor, so you can measure the differential pressure below the tool, which is very useful for optimizing motor performance, optimizing bit setup. And then more recently, or in more recent years, we've developed underbalanced and managed pressure drilling capabilities to maintain either a constant pressure on the wellbore when we're going through very narrow mud windows, or drop the well to underbalanced so that we can drill through depleted zones. So the hydraulics for this all have to be managed, and then any demands from the downhole systems such as motors, rotary steerable tools, MWD pulsers, bit pressure loss requirements also have to be balanced. And then, also coming into performance is solids control efficiency. How effectively are we removing the rock from the well? Inefficient solids control will slow down the ROP because the surface system can't handle the volume of rock. But also you run into reliability issues when you start recirculating materials. So especially if you have MWD or LWD tools in the hole, these have kind of changes in the flow paths of the ID within the LWD tools. So hard material at high velocity can start eroding the flow gear inside these tools and lead to less reliability. So managing the solids control is not only an ROP limiter, but it's also reliability of equipment. Drilling dynamics is the next problem, making sure that we manage the side forces and the dynamic behavior of the well. This is a picture of a 5.5-inch heavyweight drill pipe looking at a connection that's been worn out completely or almost completely through drill string buckling. So this is looking here, this is a top-down view of what should be a 5.5-inch connection. But as you can see, the wall has almost been worn out paper thin. And this is really because the drill string design itself and the trajectory of the well weren't balanced. So at a certain weight on bit, the drill string begins to buckle. It forces itself against the wellbore wall, locks into a helix. So as we rotate it, it begins to erode one side of the drill pipe. We can get damage to bits. So this is a picture of a bit that's experienced whirl. It's been ringed out. So you can see the edge of each of the blades been worn away and then kind of drilled down. So the nose of the bit is drilling an undergauge hole, and then we're trying to drill on these basically the flattened areas of the bit blades, so the ROP will drop down, and you're no longer drilling very efficiently. But the reason for this was the bit was whirling, so it was rotating off its natural center and giving high shock impacts on the side of the blades itself. You can also have ledges creating cuts on the front of stabilizers, where you can see this step wear on the front of the stabilizer. Hole spiraling will also give this type of wear as well. So are the stabilizers hanging up on a ledge, or have we drilled a spiral hole where it's difficult for the following stabilizers to pass through? When we start to see things like BHA whirl and stick slip, we get large lateral movements of the BHA. This is a picture of a drill collar that saw a huge amount of stick slip. So this is where the bit stalls, the drill string winds up potential energy in the drill string. It then overcomes the resistance, so that potential energy is converted to kinetic energy, accelerates the whole BHA. So you can have downhole rotation speeds anywhere between 3 and 15 times the surface RPM. So the BHA accelerates up very, very rapidly, and the surface system, the top drive, tries to compensate and reduce the speed increase it sees by dropping the power. So that then creates a stall condition. So under extreme conditions, we can get a very hard stall occurring, which will then over torque or under torque the connections. So this is completely destroyed threads within the drill collar because of these high energy stalls that were occurring. And then we also had during the slip phase associated lateral shocks as the BHA just bangs around in the wellbore, which led to fatigue cracks developing in the collar. Also BHA buckling in overgauge holes. This drill collar should be straight, but you can see there's a nice dog leg on that drill collar, and this was by putting too much weight onto the collars in coal which had washed out. So the hole had enlarged and they kept trying to force weight on bit to drill faster, but because of this enlarged area, the drill collars actually buckled and buckled quite significantly, so we now bent the entire collar. Another example of hole spiraling. This is a great picture from the North Sea of a turbine, where the turbine itself started to spiral the wellbore, and then the housing of the turbines eroded as it was passing through that spiral. And because the bit speeds are extremely high, we saw a lot of wear around the bit itself, and then this followed just by wearing out in the spiral behind the wellbore. Vibration will accelerate fatigue. Fatigue itself is driven at the RPM for the well, or RPM for the drill string, I should say. So this could be 1, 2, maybe 3 hertz. But once you start to get vibration, this can be order of 10 to 50 to 100 hertz. So you have these very large shock magnitudes and oscillations of the drill string itself, which lead to fatigue, and then fatigue leads to twist off. And then also, breaking down connection torques. This is the top of a motor where the housing actually failed, and you can see the innards of the motor. So this is part of the transmission unit that's come out. But to mitigate this, we have rotor catchers within the tool itself. So if the housing does part, the internals, get caught on a latch in here, so it's still possible to trip the rest of the motor out of the hole. But again, you have to manage the dynamics as you're drilling the well, and really control the behavior. A lot of, I wouldn't say, some people, let's say, regard performance drilling as maximizing every drilling parameter. And if you do that, you'll drill as fast as humanly possible and everything will be good. But if you put too much energy into the system is imbalanced. It really does result in drilling dysfunctions, drilling dynamics, and this will damage both the downhole and surface equipment and really counteract the whole reason for trying to drill faster, because you're tripping out for tool failures. And there's nothing we can build that is strong enough to resist the forces downhole when you start to put a huge amount of weight, a huge amount of RPM and a huge amount of torque through the system, and then trigger resonant vibration. Everything has a breaking point. So again, optimization is trying to understand where that breaking point is, what the weak links are in the system, how the BHA is constructed, and all the tools within it. Next is really real-time measurement, the quality and the availability. Surface drilling parameters are hugely important, but how often we sample these and make use of them can also have huge value. Sampling and storing data, say once a second, will smooth out all of the trends that you're really looking to identify from a drilling dynamics point of view. Sampling data at 100 hertz, 10 hertz or 100 hertz gives you huge high definition of changes. And this plot was showing torque variation and RPM variation from a stick-slip monitoring system. This samples at 10 hertz. Actually, sorry, no, this version samples at 100 hertz. So we can get this very high resolution change. If I was to sample this data every second, you'd just see a very flat line for both torque and RPM, and you'd fail to identify the problem completely. We can use the drill string internal and annular pressures as another measurement to see how effective the hole cleaning is, to identify back pressure or pack-offs in the annulus, identify restrictions at the bit, or identify restrictions in the drill string. We've got other tools that can be run which have strain gauges, so we can look at stresses within the drill string itself, compression, tension, and then we can convert that into a weight on bit measurement if we know how much is the weight below the assembly, and we can kind of tear out the values so that we remove the drag in higher angle wells. This can also measure torque, so we can look at identifying the torque and the variation in torque being applied to the bit. And some of these tools can also integrate the values and get bending moments, so we can see how much tortuosity there is in the well bore. Measuring drill string vibration downhole, again, hugely important. We have accelerometers, magnetometers for RPM, and also gyros to measure RPM if we have magnetic interference. Generally, this needs expert interpretation. So again, you've got to look at what are the data rates from downhole to surface. How can you package this information to interpret it accurately and determine the mode and dominant mechanism of vibration so you can obtain the right corrective actions. For surveying, the survey accuracy, frequency and uncertainty also has to be accounted for. So this may be just looking at removing bias from the sensors themselves, but you can also run magnetic observatories on surface and use those, especially in higher latitudes, which is a method known as IFR2 or interpolated in-field referencing, to remove the bias that we see from the Earth's magnetic field fluctuating with the intensity of solar storms or the solar wind. And we can also do corrections for magnetic field corrections based on magnetic surveys of the rock, so we can look for areas that are more magnetic or less magnetic in the rock and do what they call downward continuation surveys, so that we can understand how that fluctuates with depth and then correct the azimuthal sensors that use the magnetometers accordingly. There's also more availability of wellbore imaging, so we can look at the size and shape of the borehole, identify zones, which you can see here as the darker spots on the log. The wellbore is starting to break out. Many different techniques to do this. We can use acoustic measurements, resistivity measurements, photoelectric effect. And also, as the BHA moves past these zones, if you measure them while drilling and then rotate past while tripping, you can do time-lapse logs and see, do we have any time-dependent effects in the wellbore, be able to determine them with those tools. Now we're also seeing the development of very deep reading resistivity tools. So we have formation evaluation tools that can look, 1 to 200 feet away from the wellbore and take a really good look at the reservoir, both above, and if you're at an angle, kind of to the side. So this also helps us to kind of steer the well and make sure we're positioning the well in the most, to gain the highest level of production or in the zone that we want based on the formation properties. But again, you have to balance this positioning of the wellbore with the geometric needs and the torque and drag and so forth. So really, the first step in improving the performance is to understand the root cause of the performance itself, either good performance or bad performance. So every factor I've just discussed really needs to be assessed as part of drilling the wellbore to see whereabouts we're getting those performance gains or where we're seeing the limiters and things that would trigger remedial action. There's also a challenge around the technical complexity within each area. There are a multitude of interdependent tasks that are required to plan and execute the well efficiently. So you then have to start asking the questions, who has the knowledge about the entire process and who is controlling it? Who has the knowledge and control of the specific sub-processes or systems that go into designing the drilling assembly and operating the drilling assembly? And with all of these components or subcomponents designed, being effectively combined, both in the design phase and for the execution phase. So one of the challenges is if you don't have control over the whole drilling system, from the selection of the bit to rotary steerable system to motor to LWD system, if you're involving under-reamers or multiple cutting structures in the BHA, this is a very complex dynamic system that has to be managed, but a lot of people have very specific expertise in certain aspects of this process. So this is one of the activities that we went through a number of years ago, was actually mapping out a workflow which identified all of the tasks involved during the planning phase and all of the responsibilities during the planning phase. So the map itself, this is a representation. It's actually 9 different posters with all of the details on it. But every single dot represented as a phase or a requirement for planning the well and understanding where the wellbore needed to be drilled. So initially there are well construction requirements that set the requirements for drilling the wellbore. So we need the target location in the subsurface, where are we going to drill? We need to understand the well type, is it a production well, an injection well? Are we doing exploration wells, evaluation wells? Then we need to understand the type of reservoir, the extent of the reservoir, and the required exposure of that reservoir. The next step is to move to the production requirements. How are we going to produce from this well? What type of completions and production equipment need to be lined up to the well? Are we going to stimulate the well at all? What is the completion hole size that's required for that wellbore? Which then informs us, working back from that, what are the size of the other and depths of the other hole sections we need to drill to deliver that hole size for the completion. We need to obtain the geological information to understand where we're going to drill. Look at reservoir geomechanical analysis to optimize the direction of the wellbore for production. Also look at the surface location. Are there any limitations there? Offshore, are you close to pipelines, shipping routes, or so forth? Onshore, are you near to populated areas? Are there limitations around, the presence of lakes, mountain areas? How do we get access to the pads to drill the wells? From that point, we then need to understand any environmental limitations at that surface that location and work to those. So once that first pass of information has been determined, then we determine the well trajectory and do the wellbore integrity analysis, pore pressure, fracture pressure, collapse pressure, and then move on to the casing point selection based on the pore pressure analysis, fracture pressure analysis. Then we do the casing design, which would be the next step. And then from there, you move on to the planning of the drilling of each hole section, where you look at the fluid design, bit design, BHA design, drill string design, and hydraulics design. So for each of these various requirements, we identified individual tasks, or the individual tasks required to deliver or produce the well plan or design of service for each of those. So each one of these dots represents a task. Each task is assigned to an individual to complete. And you can kind of see by looking at the different groupings how a lot of service companies and oil companies silo themselves. You know, we have the well trajectory design, which is probably one group. We have pore pressure geomechanics doing the wellbore integrity analysis. You have a fluid design team and fluid experts. You have bit design experts, BHA design and experts. Then kind of generalists who'd look at the drill string design and the hydraulics design. But there's so much interaction and so much interconnection between these various different tasks that to be able to do them efficiently, you have to understand kind of cause and effect and the impact. So this was the next thing that we modeled out or did with this workflow, is to understand these interactions. So every line that you see here is a connection between tasks. There are two sorts of connection. There's a dotted line and a solid line. The solid line means that there is a kind of a hard connection. It means if I change something in this part of the design, it has a tangible impact on something else. So for example, if I need to change the jet sizes within a bit, this will affect my total system pressure losses, my surface pressure limits on the wellbore. It may influence the flow rates that I could use. It'll affect the MWD telemetry. So understanding the various different ways or changes cascade through the system is hugely important to optimize it. So by implementing this process, really what we learned was, giving a people an understanding of the whole environment then allows them to communicate more efficiently. So they know who is responsible for the task, but they also know which tasks they impact or tasks impact them. And then in doing that, you can develop the focus areas of the teams and the communication topics and ownership across the various different disciplines. So as I mentioned, this was really put together as a series of posters. So this is again just an example that, to complete the entire BHA design, I need a number of other workflows completing as well. So there are single tasks that need to be completed around the major design that exist in other workflows, but I also need other complete tasks like the wellbore trajectory to be finalized, the drill string design to be finalized before I can really sign off on the whole BHA design. So there's a lot of iteration that goes on. Within the minor nodes, which are the individual steps, it clearly outlined the task and clearly outlined the responsible person for that task. And then it links to all of the other nodes that are affected by that task or connected to that task. So the first one here is, looking at say the well plan tortuosity or the trajectory for the wellbore, and I can't do that until I have the first draft of the well trajectory. But then there's also an influence of the drilling fluids design, to complete this initial task. So it really highlighted the iterative nature of design and planning, but gave people a framework to work within to make sure that they checked everything off, they considered it, and then at any touch point where you needed to reconcile two conflicting requirements, that discussion occurred effectively. There's also a workshop that we did around this, was to really go through and do a performance analysis, looking at all of the challenges that may occur within a specific section, look at the consequences or the consequences of if that problem occurs, drive down to the root cause of those problems with the teams, but you're looking at it from a multidisciplinary perspective. Then by identifying the root cause, you can then come up with a solution and identify whether the solution will either have a positive or negative effect. So, one example here would be there was a high risk of shallow water flow on this risk. And the consequence of shallow water flow was, really poor cement jobs for the operation. We might lose well integrity completely by not having the surface casing cemented effectively. We might lose a slot, which will reduce overall production, overall value of the prospect. We may lose a BHA, and with it shallow water flow, we may increase the ECD, which will then break the formation down and lead to lost circulation. Driving into the root causes and how to manage these, monitoring the pressures, increasing the ECD to a limit, managing the whole washout, or looking at the whole collapse, these were the things we had to mitigate. And if we mitigate all of those, the benefit is a stable hull. If we get it wrong, we'll end up with lost circulation. But there's lots of different ways to manage the shallow water flow, from full pump and dump to begin with, to using LWD sensors to identify when the formations become sufficiently competent to trap pressure, to identifying the zone with the pressure, to running PWD tools if the well flows, to measure the actual annular pressure itself, determine the kill weight mud that you need, to deal with this. So really, in giving the teams a framework for discussion, we could then bring them into an environment where they can have these conversations, follow the framework, and more rapidly get to the root causes and potential solutions available to them. The other thing is really a limitation, I think, the performance is the planning cycle times that people have. How can we drive efficiency into the cycle time or the planning cycle time and reduce waste? So reduce duplicate efforts, reduce the time it takes to collect information, analyze information, process it, and make decisions. So a comprehensive basis of design documents were really the framework to these workshops, where they were included, where we'd identify the highest performing systems and look at the acceptable risks, but also where we change something, it was look at the risk of the problem, and then also risk the impact of the change to see whether items would be made better or made worse by that change. Also, analyzing and looking at historical wells by identifying the root causes of those issues. Now, this could be both non-productive time or invisible lost time. So we're not looking only for things that break. We're looking for opportunities to find where the limitations are within the system and improve them. The workshops recorded all the risk mitigation information during the execution, and then this is always fed back into the design team. So anything that was done during drilling is captured, and the design engineers then need to assess why was that done, how effective were those risk mitigation actions, either in curing vibration, improving hole cleaning, trippability, so forth. And then really what you run into next, the kind of the human factors that are involved in performing the work. So how do you get teams to work together? How do you balance the workload? How do you ensure they're communicating effectively? How do you reconcile differences? And this again becomes very challenging with the amount of people that you have to involve within these projects. So this is typically, from an operator's side, the major roles that would be involved in planning, designing and executing the drilling of a whole section. So drilling manager, drilling engineer, and include the petroleum engineer, for the completions needs. You have the geologist, geomechanics specialist. Depending how the teams are structured, if you're in an asset group or whether you're in departments, you may have an engineering manager if you have an engineering department or drilling department. We have geophysicists, petrophysicists involved. So these set up all of the requirements for the well and where we need to drill the hole. But then you look at the input from service company experts who configure, design and operate the equipment. There's a huge amount of different disciplines that are involved. All of these are specialists within their individual domains. There is always some overlap between these domains, but on a typical well, nearly all of these people need to have input. Obviously, there are some specialists around underbalance drilling or managed pressure drilling specialists, But otherwise, nearly every other role is involved in some form in doing the design, planning the well, and planning the execution. So again, having the frameworks to identify the teams, is hugely beneficial. Also, there's kind of a cultural or aspect to this where there's a level of tolerance for risk and the desire for change. Certain companies like to be very stable, very risk adverse. They don't want to be the highest performing, but they do want to be consistent performers. Other companies are really driving for top quartile performance, but to get there and really push the envelope, you have to have a higher tolerance for risk. You don't really know you're at the edge until you've gone over it in a lot of these cases. So the whole cultural environment, plays quite a big part in, the effectiveness and the desire for performance improvement. Do we just accept the status quo if nothing's going wrong, or do we try and push the envelope and accept the fact that we will learn, from things that do go wrong? There's also a balance between the early learning period on projects and the mature learning period. You get a very rapid improvement early on, and then once you've learned the major lessons, it becomes a lot more challenging to improve. And then this is where more of the risk assessment needs to come in, and the level of acceptance of risk in trying to push the envelope even further later on in the project. Another thing as well is mature organizations themselves really share common values and behaviors. And if you're successful, this then begins to define the norms and the boundaries of behavior within that group. So you kind of run the risk of that, groups that are perceived to have greater success actually are much more resistant to change. So they can actually either get left behind because they're not willing to adapt new processes, or you get into this kind of groupthink where they'll convince themselves that certain problems are not going to happen. Oh, we don't anticipate that happening on our well. We don't believe this is going to be a problem. Then when they start to drill the well, it's immediately a problem. So by failing to consider all of the aspects and put contingencies in place, reduces the overall chance of getting the performance gains because they're less prepared. And there's also a very natural tendency for people to operate in silos, where you can focus on a single issue. It's easy to measure the result. And also, working with your peers, you speak the same language, you have the same background, you understand the same issues to the same depth. You don't necessarily have to educate somebody else on what it is or how you do that work. The broader the teams become, the more challenging it is to manage, and the more challenging it is to share information. And again, this is one of the benefits from creating the performance workflow that I showed you earlier, was that it really informed people on what somebody else needs from them, rather than sort of being asked a question and not really knowing the answer and giving somebody all the information you have and then letting them sort through it on their own. So it's kind of challenging to manage the size of the teams and the makeup of the teams to be effective. So one of the things that we also did was to look at the required expertise around the original metrics that we had for wellbore placement, mechanical efficiency and reliability, wellbore quality, drilling dynamics, looking at the hydraulic system efficiency, and the real-time measurement, quality and availability, as to who is involved, who has control, and how to reconcile it. And by kind of putting the multidisciplinary teams together, I think it became much more efficient and effective conversations and a much shorter planning time, because issues were dealt with early and they weren't kind of held till later or held till they became last minute and absolutely critical. So really, the key that we saw to superior performance was driving metrics around, the wellbore placement accuracy, mechanical efficiency and reliability, wellbore quality, drilling dynamics, the system efficiency, and also the availability and quality of the real-time information to control the system. And by focusing in on the real metrics that show root cause behavior rather than the results, this helps us really dial the performance in a lot better. So I think a lot of the industry at the moment is really driving towards much more automation within drilling. You know, the holy grail is autonomous drilling, where you push the button and the system goes off and drills the well for you. You know, it may be a long way off in science fiction, but there's many things we can do along that path that are available to us today. So a lot of the integration can now start happening at system levels, where we can make a lot more intelligent decision making within the tools or within the surface equipment. But those systems, you know, may focus on just one aspect, like steering control, but then you could expand the system out to understand, well, steering control and hole cleaning efficiency, or steering control maximizing or managing or mitigating drilling vibration and drilling dynamics. And this really then starts to become the integration of all of the surface data and control systems of the rig with the downhole systems and the ability to control the bit face and side forces on the bit, or may be able to alter flow rates within the tools dynamically. But the key is really the data rate from the downhole tool to the surface, and where you balance that intelligence. You know, do we need an intelligent system downhole that can cope with limited updates from surface for key parameters? And will the surface system be able to control the downhole system with the same thing? Or do we need to now go to a very high data rate where it's one integrated mechanical system, where there is no bandwidth limitation between downhole and surface, and all of the behavior of the BHA and downhole system is immediate and instantaneous? I think that's going to challenge the industry, at least for the next few decades, on really how to balance those control systems out, and to integrate all of the requirements of the rigs, the downhole systems, and the need for the level of quality in delivering the wellbore itself. So this digital integration, I think, is really one of the next barriers to performance. You know, there are a significant number of different models available out there. You can use pure physics-based models, which will take you so far, but still have limits, because we have very limited, really, data from downhole to fill these models with. So there's a lot of, not a lot, but some uncertainty in the real conditions versus the model, and the physics can only take you so far. There are data-driven models where you're looking purely at statistics, previous performance, but they ignore the physics a lot of the time of why various performance levels happened or why issues happened. There are kind of hybrid models between the two, where you can use the data-driven models to examine the current behavior and then try and tune that into a physics-based model. We also have ranges of accuracy. You know, how accurate is the data input? How accurate are we defining the environment within these models? How accurately are we defining the properties of the equipment itself? You know, do we have a true digital twin of the mechanical behavior of the downhole tools, where we can accurately predict performance? Or are there limitations to the sophistication of that mechanical model with a lot of these very complicated tools? You also have the calculation, derivation. How are you getting the calculations? Where do they come from? How are you defining them? How do you validate them? It's very easy to put a formula together to predict a certain behavior downhole, but how do you validate it? How do you identify the consistency? The drilling environment is always rapidly changing. It's very, very dynamic. The whole position changes, the weight, the torque, the fluid, the speed of the drill string. Very rarely is it truly constant for long periods of time. You drill through different formations, different rock strengths. There's a lot of dynamic behavior that then has to be validated back into these, the static models or dynamic models. As I say, we've got static models, which will give you a single snapshot. You have dynamic models. There are a few of these out in the industry. They can be quite impressive prediction tools, but when you really start to line them up about, did the prediction match the actual experience, there can be a lot of discrepancies between the two. And that's just the lack of fidelity in a lot of cases, and really the difficulty, in converting the very complex dynamic behavior downhole into a model. Then we also need to look at analysis on a depth domain. Physically, where is everything spaced out relative to formation boundaries or beds, and then time domain, looking at vibration analysis, ROP, and so forth. So the real-time control systems and drilling automation, we're moving as an industry a lot closer to having these systems, but I think there's still a lot of gaps within them, and the ability to integrate kind of smarter systems. Many of them just have single set points where we'll optimize ROP, and the system is allowed to change weight or flow rate, and those are the two levers that the automated system can pull. But this can be very beneficial in a homogeneous formation, but extremely damaging if you have hard layers. So if the ROP suddenly drops, the rig tries to compensate by increasing the weight on bit, increasing the flow rate, perhaps increasing the RPM, which then leads to huge levels of stress and vibration on the BHA, leading to a tool failure. So there's much more, if you like, environmental awareness that needs to be plugged into these systems to really achieve, I think, full drilling automation. So just to conclude, superior performance is really achieved by creating these digital systems that allow you to model and evaluate performance and control the system itself. But they also have to be based around the knowledge of the team, and we need to have team structures that can drive an integrated approach. There's little value in putting everybody in a room and saying collaborate, because they don't really know what their goal is or how they interact with everybody else. But by putting them in the structures that drive the integrated approach, by having all of the stakeholders or those with a vested interest working on the same problem, certainly drives the improvement. You also have to define information structures to navigate the cross-disciplinary requirements. Who needs what and when, and also, the understanding that you have or decisions that you make within your aspect of the design have consequences in other aspects of the design and execution of the drilling system. So by having all of that mapped out and having clear responsibilities, again, improves the overall performance of the operation. And then finally, as we started the presentation with, defining the effective optimization criteria that measure the behavior you want to drive. So this is looking at the root cause of the performance and how you got the result, not necessarily the outcomes. The outcomes will tell you where things have gone well and gone bad, but they don't get you to that optimum drilling solution. So you can really look at the, what is the good design, that Ove Arps was talking about or identified as, how do I get to that overall good design? Is really by understanding the root cause of the issues and being able to address them. So hopefully, you found that interesting. I tried to make it as kind of really as comprehensive as I could to show the scope of the problem and highlight the challenges that are faced just in putting a hole in the rock in the right place.
Jez, that was a fascinating presentation. Yes, I agree, absolutely. Many congratulations. And I must admit, I had no idea of the enormous complexity of the decision making required. I mean, that slide where you showed the I don't know how many interactions were on that slide. The hard ones and the dotted line ones. It must have been over
254.
250, yeah, 254 precisely, yeah. And all those people. Anyway, but very, very interesting and incredibly timely. In terms of, I guess the announcement today, as you probably saw, that Exxon and Nabors are going to try and drill an onshore lateral well entirely automated. Did you pick that up in the news this morning, or presumably?
Yeah, something about it. Yeah.
Okay. Well, they said we'll know soon enough. So I would suggest, since we're only 20 odd people in the room, that everybody who hasn't got background noise simply takes themselves off mute. I do encourage this because it allows us to have proper discourse rather than, so I don't mind people, speaking and interrupting as long as it's reasonably controlled. It's better than me saying, please unmute your microphone. So I do please unmute yourselves, even if you don't want to put your videos on, so we can have a discussion rather than, more stilted me interfacing through Jez, which is quite unnecessary. Paul, can I ask you, please? Thank you, Vanusha. You're going after Paul. But so can we start with Paul, please, to ask your second question, followed by Manusha and followed by Gary.
Yeah. Okay. Thanks for a great talk, Jez. I had a question, and I'm not even sure it's relevant, but what you showed was these, massive connections, and it is quite scary when you see it actually plotted like that, because there is a lot of complexity involved. And that was just for planning.
Yeah.
So my question was, if you're trying to manage a well, can you hear me okay?
Yes.
Yeah. If you're trying to manage a well in real time, let's say you want to make a decision based on some of the data you're getting from the well. Obviously, you've already made those planning decisions about what BHA, what bit to use, what fluid density. So it should get easier. But have you also tried to make that connection chart for decisions around real-time changes in the way you're drilling the well, the directional?
We have, but not in the same way. Okay. The illustration we give, or the illustration I use a lot, is kind of as a bow tie. It's during the design phase, you start off with almost an infinite amount of choices that you narrow down to one design. So the workflow helps you get to that design of service or that plan. But then when you start executing that plan, it then starts to bifurcate away from there again, because things happen that you weren't planning on, or the unexpected begins to occur, or the performance wasn't as you expect. So it became very, very difficult to draw a map of things getting more and more complex, and just an infinite amount more choices coming away from the plan. But what we tended to do was focus more on areas of risk. So we'd have people looking at, say, vibration mitigation, people looking at hydraulics or hole cleaning mitigation, people looking at wellbore stability, torque and drag analysis within that. And then it was more, they're knowledgeable about the right corrective actions once that issue has been found. So it becomes more of, I want to say, a ledger where you can look in and say, I find the right subject, and then I find out what the solution is on that topic. But the interrelationships in the process are kind of already taught during that planning phase. If I increase my flow rate, what happens to the system, in terms of the downhole tool behavior, the ECD, so forth, so that's kind of inherent in the training behind that. But trying to do the same workflow map for real-time planning, it just became horrific. It bifurcates all over the place, and then it becomes almost impossible to follow. So I think by focusing on the different disciplines, I think that was a better way of keeping the decision-making tree manageable for different issues. Yeah.
Thanks very much. That's a good answer. Thank you.
Yeah.
Manusha, did you have a question? You need to come off mute.
Yes, I did. Yes, I do. Very, very quickly, please. First of all, I really enjoyed it. It was like a course of the latest drilling techniques and tools and so on. I really enjoyed it wonderfully. The question I think I have is, what is the back of mind? I think Tim and Simon also stopped during the lecture, that when designing a well and benefiting from the multidisciplinary expertise, each of them is wonderful, because you are getting teams back and forth and organizing it in time. But because the way we are having everything so sophisticated and on time, while drilling, decision has to be made, measurement while drilling, etc., etc. But that decision is not as simple. I remember my old days when I was in control of a well. I was worried because it was exploration well, the prognosis was not reliable. I would stop drilling and say, please circulate. And they resented, the drillers wanted to go quickly and so on. And then I said, can we run logs? They said, oh, no, the tools might get stuck. We want to go because shale heaving, etc., etc. So I had that resentment and the experience of crashing in my early careers afterwards and later on as well. And so who is responsible? And that is very important in these days. Everything is going to quickly, online and live. And as I mentioned in my notes, the Macondo disaster, the tragic one, who was in charge. That was, of course, beyond drilling and completion, cementing, and so on. So this hierarchy and decision-making is something which is, or should be. What is your experience as they asked, or any suggestion by anybody how to improve this? It can't just be a simple hierarchy. There are to benefit from all these disciplines. That is all, please.
Sure, yeah. No, I mean, a couple of parts to that question. I mean, to me, my view is that by focusing on the quality metrics, not necessarily the speed metrics, you know, that gets you that improves the focus on there. Obviously, aligning compensation, remuneration, and the commercial aspect is also the big driver. You know, there are cost pressures on every well that we drill. So if, you know, I would argue that if the budget hasn't been put in place during the planning phase for an adequate logging program, then they're not necessarily getting the value out of the well that they're trying to achieve. You know, so that quality metric is one of the aspects there. But then, you know, the real decision-making process and ownership, again, I think gets challenging in the way different operators are sort of organized, you know, either through assets or different departments and the ownership in there. So, you know, I really don't see a kind of a clear answer to that problem. It's driven by the culture of each of the operators, service companies, drilling contractors. You know, some will be able to collaborate more effectively. But ultimately, I think it's the commercial alignment at the end of the day that's key to everything, because, you know, it's a business for everybody at the end of it. You know, so if you've aligned the commercial aspects to the deliverables, then I think that will drive, you know, help to drive the quality that you need, you know. But if you drive behavior by saying the only metric the driller has is get days below the curve, and the only metric the geologist has is I need a full evaluation of the wellbore, and, you know, so I can establish that, you know, the entire value of the asset and then what's basically there, you know, oil in place. Those two are diametrically opposed goals, you know. So that's where it needs to be balanced, is the kind of commercial side of that delivery, you know. But where that balance point is, I think, is always going to be the interesting exercise to perform. You know.
Thank you.
Yeah. Gary.
Yes, first of all, thank you, Jez, for an extremely interesting talk. And I think you dealt with so many different aspects of the drilling process and pulled them all together quite effectively. I particularly found your comment about getting everybody in a room and trying to make them collaborate. That's very, very relevant from my experience. But, you know, finding the logical interconnections is essential. And I think one area, or maybe a couple of areas you didn't really touch on, which I think should be considered, is competence. How do you evaluate and assess the competence of the team for A, designing, and B, executing the process? I think that's an area that is particularly relevant in today's environment, where we have a lot of people that have either dropped out of the industry or you know, we're not able to spread them that thin. I think ways of doing that, perhaps in terms of evaluating risk and contingency process, is especially important when you come to drill a well. Like, so there isn't that middle of the night feeling that something happens and we, you know, the guy that's awake makes the decision. We've already gone through some aspects of what could be the logical decision-making process. But the other area, I think, as well, that, you know, certainly isn't part of your mandate, but is part of the very relevant mandate these days, is supply chain process and how that affects things. Because, you know, if I can't get my presents for Christmas today, can I get my casing on the rig tomorrow? And that sort of thing, I think, is really relevant in terms of quality and performance as well. But thank you very much. Any comments would be welcome.
Yeah, no, I mean, the process efficiency, definitely. You know, if we can deliver or standardize the delivery time for various different sections. I totally agree that has huge knock-on effects to, all of the supply chain, getting equipment bought, mobilized, installed correctly. So narrowing down, getting the performance so you have a very small bell curve on how many days it takes to deliver each whole section. It's hugely important. From the competency side of things, I think there is an avenue around simulation that would really benefit us for competency. There's a lot more people, a lot more companies developing kind of simulation systems now where you can look at the behavior of a well as it's being drilled. The focus for a lot of years was really, well control simulation being the way to train people to kill wells. But I think that, with the technologies and the modeling we're developing now, there's more of an opportunity to learn how to operate the systems as a holistic, a whole system, and then evaluate people's competencies from that on how they behave. Whereas before, you've just got to rely on getting people on a rig and seeing what's happening before they learn what's going on. So, and especially, with the move to remote centers and digital, kind of the remote drilling centers, that I think also gives an avenue to broaden people's exposure in a much shorter period of time, that they can sit and view 5 or 6 different wells, either shadowing it or monitoring it directly, but look at lots of different behavior, whereas
Right.
before,
I found that especially challenging in a way that those systems can work for you in many respects, although you won't have the beauty or the, should we say, the comfort of your company man lining people up every morning, to decide what the priorities of the day are. So it's a whole different way of working, but I think it's certainly something we have to get our arms around.
Oh yeah. But I think the acceleration of exposure is achieved through the centers. Managing the work process, I think, is kind of to the side. Or not to the side, but a different focus area. But
right.
Because you can have folks who've drilled 24 years of the same well every year and have learned nothing. Or you can do 24 different wells across the same period of time and get a huge expertise.
Great. Thank you very much.
Yeah.
Yeah, Behrooz has joined us, and he's going to be talking to us about a leadership approach to management. So on the basis of that, I'm now going to be provocative, I hope, and say when I saw the complexity, I think Manusha made this point as well, the complexity of data inputs during the course of the execution phase, not least the amount of information that's being displayed to the operators. I have to ask whether humans are best suited to this activity, or whether we really ought to be going as fast as possible towards robotics, where the decisions can be made in nanoseconds, and then to use from a different industry, try it and see. So you can make rapid changes and acquire new data based on those changes, and then make another decision again based on best practice, all the algorithms you've worked up before. I can't see how a human can do this job as efficiently as a robot with the appropriate algorithms. Behrooz, you can also argue with me on this one. Go ahead, Jez, Barrett, Gary, and others.
No, I agree. I think there's a lot of, if you like, rules-based decision making that can be performed on the raw data. I mean, the analogy I always try and use was the the glass cockpit development for airplanes. Before you had hundreds of gauges and it was all analog, and a pilot had to know what every single gauge meant and how to integrate them. And then you reach a point with airplanes now where it's a glass cockpit, it's one screen, and it displays the most relevant information to them for the task that they're actually performing. So it's intelligent enough to know when something is going wrong, and it starts to flag that information in and highlight it. But they don't have to identify it from a whole bunch of waggling gauges themselves. So there's a lot that can be done, I think, just around process management and rules-based approaches to handling the data. But you still have to have a dimension of human interaction where you evaluate conflicting decisions and determine which is better. And a lot of that comes from knowledge and from experience. And I think eventually we can get there, you know, with kind of intelligent systems, artificial intelligent type learning. But there's still got to be that validation of, has it picked the right road or not, you know? And I think that's where the real skill starts to come in. But you've got to stop bombarding people with so much data they can't think about the problem. They're just responding to what's happening that second, you know.
I've been involved in a couple of other industries where the issue of how you transition from human control to automation. I mean, the significant ones are the tube network in London, but also air traffic control. And air traffic control, probably 25 years ago, we're seeing whether or not they could automate the stacking of aircraft using computers. And the problem is that the transition period between humans doing it with a particular density of stacking of aircraft, and then computers who can double or triple the density of aircraft, is somebody's got to monitor the computer. And unless the brain of the air traffic controller is fully engaged in the process, they can't react fast enough to when things go wrong and make an appropriate decision. And I think we're going to see the same thing here, that it's not possible to be do anything other than completely engaged and in control.
And I think that, I mean, there's certain processes or drilling processes you can mechanize very, very effectively. You know, I mean, our current rotary steerable system we have in the market, you know, has a cruise control facility. You know, it samples the sensors in the tool at 1,000 hertz. These are fed into the control system. It, you know, it alters the pad force and the direction of the force of the pads almost instantaneously, and it's massively effective at drilling a straight line. You know, so if you want to drill a tangent, a vertical, horizontal, this has real control over that quality, because the control system's embedded in the steering head. You know, so I think things like that can be really efficiently done. But then other aspects are, well, what happens if the hole starts to deteriorate? The system knows nothing about hole quality, so it'll make recommendations on an assumed wellbore diameter, but then you have to go in and override it and say, no, those decisions are now bad because your environment's altered, you know. So it's the extra level of knowledge of how environment changes that the system itself doesn't inherently know anything about, you know. And I think that's the real challenge with the drilling automation, you know, is to make something that is totally aware of how the rock changes, the fluid changes, the inputs from surface change, to be able to control itself downhole. Yeah.
No, it's a challenge, but I don't suppose particularly significantly different to self-drive cars or something like that, which I guess are probably moving the decision making.
Well, yeah, but the self-drive cars, all the information is instantaneously available to the car.
Yeah,
you know, it can look around it, it can see, it can respond. Whereas with the drilling system, you're putting something maybe 1 mile, 2 miles underground away from its major energy input, and that has to communicate. So there's a, you know, the techniques may be similar, but the process and the time lag is very, very different.
Yeah, that point. I mean, I guess we've been going a fair amount of time more than we budgeted for. Is there anybody who wants to make any final remark, tangential, or a comment that might summarize the last hour and 3/4? Anything anybody wants to add as a final comment? And well, whilst you're thinking about that, and I will give you some time to do so, I just say that I think we should have a short break before Behrooz starts talking to us. So after we finish now, I would suggest we probably pause for 20 minutes to give people a chance to get their breath back and comfort breaks, etc. And then after that, Behrooz will join us and start his talk. So Jez, no one else has come up with a remark to close this up. So I just have to say, well, an absolutely fabulous dissertation on where we are with drilling now, really riveting, and so much potential, but also pretty mind-blowing what you've told us. Thank you again so much, Jez, and stay on for Behrooz talk if you wish. For everybody else, I suggest that we reconvene at 7:05 UK time. That's just on 19 or 20 minutes, and then take a break in the meanwhile. And thank you all for your attention. Bye-bye for the moment.
Right, thank you.
And yeah, I've just been told that we're recording. And just to say the obvious, that we're delighted that Behrooz Fattahi has agreed to present to us. For those of you who don't know, he was the 2010 president of SPE, and also then the president of the AIME as well in 2014. So really an amazing track record of leadership within the top of our industry. And with that in mind, I'd like shortly to hand over to him. And the title of his talk is a leadership approach to management. I also should mention that Behrooz now is part of the EnerTrain Institute. And so Behrooz, the floor is yours. You're on mute, I think.
Not yet, you're still on mute.
Okay.
Do you hear me?
Yes, we can.
Yes, we can.
Yeah.
Okay, thank you. Although I live in San Diego, but I'm talking to people in London, and that's a pleasure. I've been to London a few times in the past. Last time about 3 or 4 years ago, but my official position as the SPE president, I was there in 2010 and gave a lecture to the section. So again, it's my pleasure to be here. Today, I want to talk about a very interesting subject, and that's leadership. A leadership approach to management is the most important part of soft competencies in my mind. And I will try to explain that to all of you. And I hope at the end I have convinced you that as far as leadership, we have ways to go, but the way forward is clear, and all we have to do is just get on it and start driving. So let me see if I can. There we go. Okay. My discussion today is actually in 3 parts. The first part, I'm going to present to you why I am worrying about the leadership practices and the ineffectiveness of the management these days. And that is really both in government and private organizations. Then, after I hope I have conveyed my thoughts to you, then I will talk about management and leadership and why are they the same or different. And I try to prove to you that they're different. And then at the end, I present a new model, which I have put together. And it's a simple model, and when we get to it, we get into more details. First, one of my biggest worries is lack of engagement of the employees in many different organizations around the world. A Gallup study showed that 82% of the time, companies fail to choose the candidates that are right for the job they have in mind. That doesn't mean they are not talented. They are talented, but they are not recruited for the right positions. And therefore, when they join, they become unhappy and disengaged. And a study by Gallup also of hundreds of organizations throughout the world, and that's throughout the world, over 20 years period. And in fact, they talked to or interviewed 27 million people around the world. And they showed that in the US, 33% of employees are engaged and the rest are not engaged.
Behrooz,
And
Behrooz, I'm sorry to interrupt. We can't see your slides. Do you want Adam to share the slides, or are you able to?
Let me see. I thought I shared my slides.
Screen. We can see. We can have a video of you, but not of the slides. Maybe you should share a different screen. I don't know. But if you have, then Adam can do the slides instead.
Either way, it's fine with me. Do you want to do that, Adam?
If you try sharing first, because I don't know if I have a copy of your slides. So if you just share screen, I think you've shared it in the breakout room, but not in this room. So it should work.
So I'm learning this thing, and my share screen is gray. So somehow I'm not able to share my screen.
Adam, is there any particular reason why Behrouz's screen is gray?
Let me try something. Did it work
Okay.
now?
Yeah, now it's working.
Okay.
There you go.
Sorry about
Do
that.
you, do you see me now? Or
Yeah, it's either
my
delightful
screen?
grandchildren.
Okay, so that's my slide.
Thank you. We have to see it perfectly now. Thank you.
Okay, so let me get back to the last slide. And as I was saying, only 33%, or a third of US employees are engaged at the workplace. And over the years, it has been sort of the same. And in fact, I looked at the most recent statistics, and it's about the same. It's probably up to about 34, 35%, but not much higher. And that's in the US. Around the world, the average, however, works as 13%. In other words, 87% of the people who are working in different corporations around the world are engaged only. 13% are engaged, 87% are not engaged. So this is a chart that shows how different regions of the world are doing as far as employee engagement. The United States, as I told you, has about 30-some% engagement, and that's the white bar. And then we have as low as East Asia, which is only about 5 or 6%. So although US is doing better than many parts of the world, that's not really something to talk about. We still are disengaged as a whole in the corporations and the offices or workplaces. The next problem is the poor results. And of course, all of these are interconnected. Only 7% of the CEOs believe that their companies are building effective world-class leaders for the future. And that's a shame, because companies should do that. So these army of leaders come into work and lead the businesses. Only 10% believe that leadership development initiatives are working for their companies. And I will talk about that a little bit later under the topic of skilled incompetence. McKinsey's study also shows about the same thing. 11% of more than 500 executives thought that the leadership development interventions achieved the desired results. And so it's very low, 10 or 11%. That's the best they have done so far. In terms of execution, the execution of management is poor. 50%, 58%, almost 60% of the managers said they did not receive any management training. They were just appointed to a position either by knowing other people or by showing some competence in technical matters, but that was not enough to be able to be an effective manager. 89% of the managers believe employees quit because they find more money someplace else. While if you ask the employees, 12%, only 12% leave companies for better money. Almost 90% leave because they are not happy. They're not, and mostly they're not happy with their immediate manager or the company management line. The Harvard Business Review study shows that 60% of, almost 60% of the people say they trust the strangers more than their own managers. And that lack of trust is shameful. That's not good for the business. Almost 80% of the people who quit their jobs cite lack of appreciation as the reason for leaving. And 53% of American workers are unhappy at work. That's a great number of people who are not engaged or who are not happy at work. And then one of the important aspects of the problem of management today is the skilled incompetence. And that is, a lot of the managers feel that they're skilled. They have gut feeling that they're born as managers, and that comes to them naturally. And in some cases it might. But overall, soft competencies and management and leadership also, just like technical matters, need training, formal training. So this is called a skill. They feel that they're skilled, but when they implement their way of doing things, it ends into undesirable outcomes and therefore creates incompetence. So that's called, in soft skill terms, skilled incompetence. You do what you feel is right, and you get some results, but they may not be the right results that you are expecting. And such poor practices can become very expensive for the corporations and the companies. So I hope I have convinced you that we have a problem. Now, the extent of that problem you may have a different idea of, but it is, according to these statistics by very authoritative companies, is very concerning, at least. So I want to talk to you now about what is management and how's leadership defined. Are they the same or are they different? And why do I believe that soft competencies play a critical role in a successful transition from a manager to a leader? So let's look at the terms that are commonly used around the world in corporations or workplace. Terms such as manager, leader, lead, head, chief, director, supervisor, etc. And all of these are interchangeably used with confusing and mixed descriptions. You go from one company to another, you may be in the same position level, but you may be called different as far as your titles concerned. And titles usually, these are titles that usually refer to official capacities in a corporate ladder, and positions that are designated on an organization chart. And so referring to those people in charge of, they all refer to those people who are in charge, of people and processes. The responsibilities of these titles are coordinating efforts of a team, managing utilization of financial and technical matters, and human resources, of course, monitoring KPIs, key performance indicators, and reaching milestones. That's the job of a manager, of course, and then are accountable to hire managers, leaders, and board members, etc., depending on what their position is in the organizational ladder. But when we talk about management and leader, I hope from now on we start asking a little bit of a question. I know these are interchangeably used, but the first question we should ask is, are these terms refer to groups of people or attributes of people? For groups of people, both terms, managers and leaders, mean very similar, referring to those in position of control, such as leaders of a country, leadership of a company. These are a group of people who are in charge, who are in position of control. But if you're talking about attributes and we refer to leaders, those are very different. A leader in a company could be a person in the mailroom. It doesn't have to be a CEO. Leadership is an attribute that anybody can have or be trained for. So it is independent of position. Most of you have probably played checkers and chess. And this is an example that Harvard Business Review used in order to explain how managers are different. Some of them are checker players. They look at everybody on the checkerboard as the same people, same type of people. Checker pieces are uniform. They move uniformly in the same way. So to those kind of managers, the checker players, everybody in the team is the same. They're no different from one another. In a chess, however, the pieces are different. They have different shapes, different moves, and they can do different things, these pieces. So the managers who are chess players, they look at their people differently, and they try to understand each of those people in their own way and find out who they are and how they can do better. So differences of traits and talents are just like blood types, and they cut across superficial variations of race, sex, and age. And so these kind of managers, the chess player managers, are more successful in understanding the people who work in a team. McKinsey study back in 2015, actually, somewhat recent, showed that the more soft competency actions they bring into the companies, the better the better success is achieved by their business. And what are these soft competencies? Is focusing on communication, engaging people, leading by example, enabling people to reach goals. So they proved that they have proved that bringing this into the company business alongside technical, of course, will help the bottom line, the business of a company. And those who are more productive, they're also rated as the best in their companies. So this is somewhat obvious, but it also confirms that the people who are at the 90 or 100% percentile or group are the ones who are equipped with soft competencies. Another chart by Leadership Circle shows that the more effective leadership, the better performance by their company or the organization. And this comes from about 500 executives who led these companies. So they saw these things were helpful when they implemented. So what are these soft competencies that were helping companies' business? A survey showed that the most important to most everybody around the world is high ethical and moral standards. That came at the very top. So a company that observes high ethical and moral standards are, it's the most successful company in their business. Then providing goals and objectives, communicate expectations clearly, flexibility to change opinions, is committed to training people, communicates often and openly with the people around the company, opens to new ideas and approaches, and creates a feeling, and that to me is very important, of succeeding and failing together. So everybody owns the project, from the very top to the very bottom. They are sharing their successes or their failures. It's not pointing at single people and blaming them for the failure. help grow into a next generation leader, that's important because these are the people who need for the continuity of the business or the success of the business. And then safety for trial and error. You know, employee is allowed to try things and different initiatives. And although he or she may fail, but he or she is not going to be punished. So now we have talked about the differences between leadership and management. And in the first part, we understood that the status of management in the world in general is in trouble. So I have come to propose a model for transforming managers, just managers, to leader managers. In other words, to people who own that management skill, but on the top of that, they understand, they have the attributes of leadership that they can apply. And I call that, for the lack of better name, MLM, or managers to a leader manager model. But before I get to that, I'll give you an example of one example of many models that exist for this conversion. Deloitte, for example, which is a big company, they have a management or a conversion of managers to strong leaders a model that they call a capability leadership approach. What they do is they say, okay, if we take a manager and train him for what I have shown in this slides, different competencies, then at the end, he or she will become a strong leader. And if you look into all these competencies, the two white arrows are purely management skills. Make business decisions. Obviously, that's a management skill. Know your market and innovate to stay ahead. Obviously, that is a management or a business type of skill. But the other 6 skills that Deloitte has identified are soft competency skills. Inspire others, get teams to achieve results, develop people for competitive advantage, set vision, direction, and compelling course of action, persuade and influence in all directions, and collaborate with others. These are all soft competencies. So you can see that Deloitte creates this awareness of you have to be equipped with soft competency attributes before you can be successful in converting your people from a manager style to a strong leader style. However, some years ago, I ran into this statement by Albert Einstein, which he said, in theory and practice are the same. In practice, they're not. And that at the time reminded me of dancing waltz, for example. The steps are very easy, or tango. Steps are very easy. You can learn them in 15, 20 minutes, maybe half hour. But if you don't practice, or if you don't do things smoothly, you will not impress an audience. You will not be invited into Carnegie Hall to dance for people. So you may be very good at the theoretical side of things, but not very good at practical part of the thing or segments of the thing. And that's a very peculiar part of the soft competencies, is that it has to be practiced. If you just are aware, that's not enough. You have to practice it in order to avoid the skilled incompetence. If you go to a training, learn all about soft competencies, and then come home, back to your company and do what your gut feeling said it was right and you knew it all along, that is again, you're continuing in this skilled incompetence path. So having understood that what Einstein said, I said, okay, my model, going from a manager to a leader manager, should involve a continuity of practice. I called it a practical leadership approach to management. The first step, of course, is awareness. You have to be trained. You have to become aware of what soft competencies are. But then that's a learning part. So when you go back home or when you go back to your place of work, then you have to show that you're soft capable. You have to show that you can practice what you've learned in a smooth way, that you can handle different people and the human side of the business. So while managers do the management at the project level, the leader managers, on the other hand, do their projects at the project and people level, both together. So the important part of this is that middle circle, that it goes around and around and around, because soft competencies are quite expensive, like technical competencies, many different branches, and you have to be trained for a lot of these. You may be able to do some things on your own, but it's very can become very complicated, and therefore my best advice is to try to take some of the courses from in a formal way. So what are these competencies that I'm talking about to go from learning to practicing? And this is an example, could be hundreds of this. Goal setting, influencing, system thinking, diversity and inclusion. And to that, I have to add equitability, being equitable, building confidence, being positive, teamwork. Conflict resolution is an important aspect in teams these days. Knowledge transfer and leading by example. And this is only a handful, and there's hundreds of these attributes that you have to become experienced with and competent with. Now, when you look at an individual, and let's say you know, a young person who gets in a company, this person goes from an individual aspect of mastery level for competencies, for soft competencies, to an interpersonal, eventually to an organizational, and finally to integration. So let's see what these steps are. Usually in the first year or two, a young person looks at himself to find out what he or she is capable of. And that's the process of discovery. He looks around, and of course, he cannot forget about his technical work that is assigned. But on the side, he has to see, in terms of soft competencies, what is it that he is capable of? Self-discovery, and try to fill gaps by training or by reading and talking to other people. After a couple years, he becomes a little bit brave and gets more into team discussions and work with a number of people around him or her. And usually these teams are different branches of technical people, facilities, geology, reservoir production, different people who may be talking a different language at different parts of the you know, company, and also maybe people from different parts of the world. After a few years, whether he or she is in a technical ladder, on a technical ladder, or a managerial ladder, eventually he or she will lead a few people. And that's sort of organizational skills. You learn how to apply what you've learned in the past few years to create and to manage an organization. And eventually he or she may become at the very top of the pyramid, become a big manager or a CEO and lead a whole company at different parts of the world, in fact. So that is the process of awareness and learning kind of growing into practicing in years of experience as you move in your career. Before I get into any other things, I want to talk about the brain structure a little bit and bring to your attention how soft competencies get into play, and a lot of us may not be aware of in our decision making. Brain, of course, is made up of many different components, but two important components are the limbic system, which is sort of at the base of the brain, and the rational brain or the logical brain, which is kind of in front, behind the forehead here in this area. Everything that we feel or we see or we hear, all these sensory signals come through the stem of the brain into the limbic system first. So the limbic system is the first part of the brain that becomes aware of what's going on outside in the environment around us. If we hear something, we show a reaction. If we see something, we show a reaction. These things take hundreds of a second. They're very fast. But the limbic system only houses our emotional life, including long-term memory, formation of memories, motivation, and emotions. So limbic system is only equipped with emotional tools. So naturally, our first reaction to the senses that has come to our brain is emotional reaction. Now that's good, but the limbic system says, okay, I'm going to send this information now to the rational brain and let the rational brain do some work and modification. Rational brain next receives the signals with the emotional information that's added to this decision that is purely emotional at this point, and then adds logic to it because it's a logical brain. So it modifies it, sometimes very little, sometimes a lot, and sends it back to the limbic system. Limbic again looks at that information and modifies it, sends it back to rational. And this iteration takes place hundreds of times in very few seconds. At the end, the outcome is a decision that is the result of a combination of the effects of logic and emotion. Now, not all the people have the same strength of logic or emotion in their final decision. Some people are more logical or rational. Some people are more emotional. And therefore, but what is for sure, what is certain here is that the decision that's been made has attributes of emotion and logic in it. For the logical brain, of course, 1 + 1 is always 2. But for emotional brain, 1 + 1, some days it's not 2. Some days might be 2, but some days could be 5. So because it deals with emotion, it deals with people side of the business. So that combination is important in 2 ways. One, that emotion comes into the final decision. And number 2 is your emotional system is the first part of showing a reaction and showing a decision. So a lot of times you jump into reacting to someone or something that is said that really has not been analyzed well by the logical system. It's so emotional. For example, you hear an explosion, a big sound, and you jump. And you don't know which way to run, but you know that you have to run. That's not logical. Logic comes back and says, okay, you may have to run to the right or to the left, or go back and help to whatever happened in there. So these are all important here. And therefore, our final decisions, anywhere you are, whether you are in the corporation, your office, or you're at home and working with your team at home, your spouse and your children. This is the same anywhere you are making decisions. So I want to go back and emphasize the differences between management and leadership now. Management, the managers do things right. You give them a project and they do it right. Good or bad, they do it right. But leaders do the right things. If something is not right, they don't do it. So they do the right things. Managers are in the position of authority, while leaders are in a position of motivating and inspiring people, create enthusiasm. Managers are commanding, pushing, and expecting. They have deadlines. They have deadlines to meet. But leaders encourage, pull, seek, and go after people's commitment. Managers ask people to follow. They say, follow, I know where I'm going, so you follow me. We'll get there. The problem with that is when we get there, nobody owns the project, but the only manager does, because there has not been any learning or responsibility shared with other people. On the other hand, leaders encourage initiatives. They go back to their team and they tell them, what do you think? How do you think we can do this project better? Managers encourage order and discipline. That's a good management style. But leaders encourage change and movement. Managers drive, reward, and reprimand, while leaders coach and develop people. That should be part of the management style, to develop the future leaders. Managers are reactive, strategizing for short term because they're under constant pressure to meet the deadlines. Leaders, on the other hand, are proactive. They develop vision for long term. So you can see that each of them have good and possibly poor attributes alongside with them. So the best thing is just to put the two of them together and be a leader manager that shares the attributes of a good management practice and a good leadership practice. So if you're in an organization, what do you want to be in that organization? Very strong management or very strong leadership, or where in that matrix? If you are very low, of low strength in the management, people are usually unhappy. And if the management is low, the management style is poor, the processes are chaotic because there's no order, there's no management trying to push for the deadlines and get everybody in line to arrive at the final point. But if you combine it with the leadership, that's where you want to be. You want to be at the right-hand upper quadrant of an organization, which combines the strong leadership and strong management together. Under that kind of environment, processes are very stable, well-planned. Bottom of initiatives, it's not follow me anymore, it's we are all together as a team. Sometimes the leaders stay in the back and let the team grow and learn, even if it's by mistake. They handle short and long-term visions. They're very productive, people are happy, and not only the company is operationally focused, but also people focused. So in this slide, I just want to express three things here of what we have heard today. While managers plan, organize, and measure values, such as KPIs, leader managers take additional steps of inspiring, motivating, enabling, and adding value. So that you can see what an excellent combination if you can combine the two. The key to success for an organization is to transform its managers to leader managers, from soft through ongoing process of soft competency, learning. And as we said, remember, we said awareness is good, but not enough, followed by effective, soft, capable practicing. And it was practicing is very important and required for a success, for a company to become successful. And that's what the MLM model says. And then starting with individual soft capable practices, organizations can avoid potentially lethal threats to the future. And this is, like a department. If it grows into, from a management type of style department to a soft capable practicing department, then that cannot grow and become and kind of get the whole company become that way as well. So I'm done. Thank you for allowing me to have this opportunity to speak with you, have this conversation with you, and I'll be happy to answer questions if you have any.
Thank you very much. There is a fascinating talk and really rather inspiring, maybe leadership management there, or manager leader. So can I ask you all to unmute your microphones so that you can simply have a discussion as you want? Anyone who would like to, Adam, did you want to start with a question or a comment?
Yeah, sure. Behrooz, thank you very much for this presentation. I think I've seen the manager and leader kind of differentiate before, but you've organized it extremely well. You've said that it's becoming harder and harder, and we're seeing challenges. Do you have any insights on the change of team sizes and how many people a manager has to manage nowadays? When you read, for example, at tech companies, they talk about the 2 pizza rules. You should have a team that is a size that can be fed by 2 pizzas. But I see, for example, my manager, I really enjoyed working with him, but he has like 18 people. It's way more than 2 pizzas can feed. Is there correlation between the managers don't have skills, or the organizations are set up in a way that does not allow them to succeed?
I'm with you, Adam. I think teams ought to be small to be effective. I always wanted to have a smaller task force or smaller teams to manage. It's easy to establish that people-to-people kind of relationship. If the team is too big, then you may try hard, but it's only 24 hours in a day. And you may not have enough time to really relate to people. But at the same time, you want to have that natural relationship established. I worked for Shell all my life, and at one time I had a manager, which I loved very much, a great person. And these were in early 1990s, which the consultants at that time said, okay, let's quit the department type of a style of organization and get into multidisciplinary teams. And you have to, and told the managers, you have to establish relationship with your employees, with your subordinates. And this guy really wanted to do what they said. So he came up with this idea that every Tuesday afternoon, I go and visit my people for 10 minutes and ask them about their kids and their spouses and their lifestyle and where they went for the weekend and all that. And so at Tuesday afternoon at 1:20, I saw this person at my door, and I knew what he was going to ask me because, after a couple of weeks, it repeats itself. And what he was going to ask me And it became very superficial, very artificial type of communication. So when I say practice soft competencies, is make it natural. It doesn't have to be scheduled. It can be anywhere, and but you have to do it, and you have to do it in a nice way that you don't interrupt the natural way of communication with any person. So naturally, smaller teams are better, and like you said, 2 pizza rule is a good rule. But then that's for lower level managers. Then you go up and you have a bigger team, you know, like a department to run, and then you have a company to run. Even at those levels, you can establish those relationships. I had a CEO of the company walking through the hallways at least once or twice a week, and stop at different offices and talk to people, not the same office, but different offices of people, and asked, you know, said hi and how are you today and what are you doing and so forth. So that's a way to do it in a bigger organization if you have one. And then, of course, rely on your lower level managers to also be trained and run their departments properly.
Manusha, Adrian, you both come off screen. So yeah, Manusha, you want to ask or make a comment?
Well, I have some general comment, or I would say question, or sharing my personal experience, that I think a challenge for both a manager and a leader is recognizing people, understanding people, and personnel management to understand individuals, because it is that judgment which makes a company successful, allows promotion. Otherwise, as the classical definition of bureaucracy is, people perform and show themselves that they are good, competent, nice, they can manage, get along with people, and they get promoted and promoted ways and means, and they get to a level that they're incompetent. Incompetent, they can't do their job, and then they remain there. And they remain there, and that they become indifferent. And the problems you mentioned at the beginning with our different statistics of how in America people have interest or are disinterested in their work, it comes. So I'd like to say that in addition to all, on top of all these, both leader and manager should have the personal ability to talking to people, understand their characters, and that is not easy. It cannot be taught in a business school.
And those
That's
are
all. As a food for thought.
Absolutely, and those I mentioned in my presentation, that these managers are the chess player managers. Those people look at their employees or their subordinates, and they see different talents and different levels of talents, different capabilities in each person, and they assign them work that is very proper for that person, rather than giving something, you know, to everybody and keep some people unhappy. And so I've been on the 2 sides of evaluating people, the performance review, and I tell you, that's the most hated process I have dealt with on either side. And the reason being that this is another process that's been taught to the managers, and they tell them you have to do it once a year because we need it for promotion and HR purposes. But you know, after 365 days, my manager sits in front of me and says, 360 days ago, you came to work with shorts on, just an example. And that wasn't proper dress for the company. So I'm going to punish you now for that. And you get a ding for that. Or 200 days ago, you did not treat your fellow employee well. Well, my comment to these kind of processes is, for this kind of processes is that one should remind me right away. If you see something improper from me, that day walk into my office and for 5 minutes, sit down with me and, among other things, bring up what I've done wrong and make me aware so I don't repeat it for the next 300 days waiting for my performance review. So I don't think performance review process is a good process to recognize talents or reward or reprimand people. I think it's a very unfair way of doing it. I think it has to be a continuous process. But also, I agree that some managers are just given a chair and a position because they probably knew someone, or in most government organizations, they go by the years of their service, regardless of what their competency is, and they get to some point and they are not trained for or not really capable of managing or leading a team that big or that extensive type of work. So I agree with you, Dr. Takin, and it's good seeing you, by the way.
My pleasure. Thank you.
Adrian.
I've got two. Fantastic talk. Well done. That was really good. So I've got two questions. One's technical, so let's get that one out of the way. So with all this psychometric testing, why can't they recruit the right people? Because I'm not convinced that these 33% of the employees that are engaged and the rest aren't. There's a lot of people who are in the right jobs and they're not engaged. So I'm not too sure. One of your points was that companies aren't recruiting the right people. So surely that's a technical thing through psychometric testing. There's so much theory about that. So they must be getting the right people. It just must be the positions are being poorly managed and poorly led.
Well, Adrian, thanks for the question. That's a very good question. I did not say that the people who were recruited may not have been talented. I said they were recruited but put in the wrong place. And because the leadership style was not, and only, HR went and recruited people and put them in some department and gave them some assignment and perhaps no training in the next few years because there's so much to do. So that is a problem, but also, let me give you another statistics, which is more shocking. 50% of the people who are recruited, and this is worldwide, leave their companies after 18 months. 50% of the people who are recruited leave their companies or their organizations, I should say, after 18 months, year and a half. And imagine how much time and how much expense has gone into recruiting a person. Sometimes exorbitant bonuses and travel expenses and getting people to come to the office and talk to different people, taking their time and, and so these are all expenses, but they leave after 18 months because the newcomers find that they are not in the right position and that they cannot get along with other people for different reasons, sometimes personal, but also sometimes the culture in that company is not accepting of them. So it's shocking. But the 33%, it's really along studies for 20 years, 27 million people. So, and it's done by Gallup, and which is a good organization. So I tend to believe it, but I was shocked like you to, when I started reading and understanding and digesting it too.
So my daughter's just started her career, and so her company, they go through a lot of people, but it's just the people that leave, they're just not being looked after. They just feel they're not valued and stuff like this. So it's more than just the psychometric testing. So I think it's actually that, as you started off saying how ineffectual companies were and how incompetent and poor execution, actually it's worse than you're saying. It's just that the data's not there. Or when people leave companies, they don't say, oh, this was such an awful place, you never looked after me and you never trained me and stuff. They don't want to say that when they leave. It's like when you go to a bad restaurant, people just don't go back. Anyhow, that's good. Thank you very much. So that's a technical question out of the way. My other question,
You're quite welcome. Thanks for the good question.
Maybe it's a bit more complicated than you're actually portraying. So, and we're seeing this with sustainability. At the moment, everyone wants to be part of the solution, but there's no leaders out there. So
exactly.
You mix your leadership and leaders together. So I agree with the whole presentation if it's managers and leadership. So we all know what managers are like. And to me, leadership is about motivation. It's basically getting the ship to move forward. But leaders are different. So I think taking your stuff and adding an extra section on leaders, because to me, good leaders are about willingness to take measured risks. It's basically using foresight and based on insight built from experience. And also it's about opportunities. Leaders often just sit in companies until it's the right time and right place. And then because no one's leading, someone has to, they stand up. So to me, that is slightly different. In fact, it's more different than between being leadership managers. So how about that question?
Right. That's right. And let me also add that, in addition to what I said, the soft competencies are important, and there is tons of soft competency areas to learn and become aware of. Leadership is the big umbrella. If you are a leader, if you know everything about soft competencies under that umbrella, if you don't know how to respect other people, you're not a leader. If you don't understand diversity, you're not a leader. If you don't understand or don't know about conflict resolution, you're not a leader. So, leadership is not an overnight thing. And, converting a manager to a leader manager is not an overnight thing. It's not even a 2-year or 5-year thing. It takes a whole life. And even by the end, you're not done yet, because there's so much to learn and so much to practice and become good at. So, the science of soft competencies is somewhat new. And there are some resistance around the corners of technical, gatherings or conferences against that, we don't want to deal with that touchy-feely stuff, but to me, those are the fundamental, fundamental part of our organization, particularly since from 1990s, we went into team, multidisciplinary teamwork workplace. So it has become more and more important. And now a lot of the universities around the world are teaching, instead of elective courses, they make their students learn soft competencies. Some entrance exams to grad schools include soft competency questions now. So people are paying more attention, but it's going to take years before we have leaders in companies that are true leaders.
Again, I just feel that sometimes when you're saying leadership and leaders, to me, it's more than what you're saying. So I've been a consultant the last 20 years, so I've virtually seen every single organization that's fully existed. So I've seen lots of management styles and leadership styles, but also the problem with what you've highlighted at the beginning, I think it's because of lack of leaders. So you have to use the word risk and opportunity and basically insight. So a lot of leadership is built around motivational. So it doesn't mean you actually need much insight anyhow, apart from having, as you're saying, soft skills. So that's the only thing I'd slightly question what you're saying, but fantastic, well done, brilliant.
Yeah, and motivation is a soft competency anyway. Inspiring people, motivating people is soft competency, and it's part of the family. So anything that deals with the human behavior and human-to-human relationship is soft competency.
But would you say, like a chairman of a company or a managing director of a big CEO corporation, were they good leaders, or they have leadership, or are they just good managers?
Well, I said in one of my slides that a true leader in a company could be the person in the mailroom.
Yeah.
And so it doesn't have to be it's ideal that the CEO of the company is a leader. That's ideal. But because we have started only recently, a lot of our current company leaders are not true leaders. They don't have that kind of leadership. They've got there under the old system, but little by little, and particularly it was very encouraging to see that the SPE young members, they really are going after soft competencies. They're trying to learn because they have recognized that this is an important part of their future career, success in their career.
I still think there's something more than these hard competencies and soft competencies. To be a true leader, it's like 1 or 2%. The leadership is usually about 10 to 20. The managers basically are probably only 60% of the company could be a manager.
Mm-hmm.
Now, I'll hand you over to Tim, so you've got more questions.
Please come in if you have other comments or reactions. I've got a couple of things that came to me whilst I was listening to Behrooz and Adrian talking, and that's actually when I did my MBA in 1987, a fairly substantial chunk of that course was about self-awareness, and we were taught recognition and acceptance of the fears and the processes within us and the self-doubts within us and our core limiting beliefs. And the reason they were taking us through a quite painful psychological process was they were saying to us, until you understand yourself and recognize and accept who you are, you won't be able to go out and fully understand what those around you are thinking and doing and how best you can interact with them. And so the whole thing for me, I mean, you encapsulated it, Behrooz, in a fairly common phrase of emotional intelligence. And I would add to that spiritual intelligence, not necessarily a religious basis, but those are the kind of, it's got to come from within. And when you are more comfortable, which comes with age and acceptance and understanding of what life's about more, then you become more able and more human when it comes to interacting with other people. And I would say somewhere in there, picking up Adrian's point about leadership, to me, the thing about being a leader is that you have to be sufficiently comfortable within yourself to be fully exposed.
Absolutely. And
you're sitting there.
This is in an agreement with one of the slides that I had, and I said the process of self-discovery may take a year or two before you really start interaction with other people around you and with your team and others in a proficient manner in terms of soft competencies. So it starts with discovering yourself and then becomes interpersonal with other people and then organizational and higher up. So, and it takes, for some people, they discover themselves because they're eager. Younger people these days are very eager to learn soft competencies because they are now getting used to see some of these things or hear some of these things in their colleges. And so they get into the place of work and they start learning these things. But you're right, you have to discover yourself and understand your capabilities before you venture out there and try to, establish relationship with other people around you. So, but even then, things are not gonna be easy from then on. I started in the line of soft competencies when I was a young engineer. But I was thinking about it, but not doing much about it until I started with Shell in New Orleans. And my new job that they had assigned to me was to take over a position that was being vacated by another engineer who was being laid off. So it wasn't a happy situation. It was tense for him and kind of tense for me because I had to understand his situation also. For whatever reason he was being laid off, I was replacing him and he wasn't happy about that. So they asked him to show me in a couple days what he was doing so I could take over his job. And I was understanding the situation and having some background in soft competencies. I tried to be very careful to go through this two-day process very cautiously. So day two, here I am, and he explained to me something about the reservoir that he was doing. And I thought that was a brilliant approach. But I, as a young engineer, I wanted to learn it so I could repeat it. So I said, X, I don't want to say his name, why did you do this? And so to me, that was a naive question. I wasn't trying to insult or trying to say something bad about him, but he became upset with me suddenly and said, do you know of a better way of doing it? So he became very defensive to a naive question that I posed. My intent was try to understand what he was doing and be able to repeat it. He tried, I was questioning his work. And so even when you're careful, you make mistakes like that, or you run into situations like that. So it's it's tough, but at least you can minimize the mistakes of mishaps.
Yeah, and 20 years later, you would have known how you would have felt anyway, so you wouldn't have asked a question.
Exactly. Exactly.
Okay. I mean, this is really fascinating. So Behrooz, it's a real pleasure to talk about this, and not, as you say, not often enough spoken about. There was the EE, our competitors that I'm also involved with, study looking at the top 10 attributes.
That's right.
Value. Oh, you've seen the same one, yes. And I think the top 5 or the top 6 were all soft skills, and the last 2 or 3 were actually technical brilliance or whatever it was. And that's really what it's about, isn't it?
Right. Actually, I was very encouraged when I had my first talk on the subject, which is entitled a soft transformation approach to career success. And I gave that a couple years ago, 3 years ago, as a DL.
Yeah.
And worldwide, I had a great number of people who were interested and asked very nice questions, seeking advice on different things they were doing. So that encouraged me, and I came up with this second talk, which I presented today to you guys.
Something that came into my mind as you were saying that, because you talked about around the world, and I just wanted to pick up on the other issue that constrains us all, which is the societal norms in which we live. I mean, now you're seeing all that sort of drama about sexual identity and gender identity, but those sorts of things create the environment in which we all live and try and operate and try and move around in an effective manner without causing a ruction unless we particularly want to. And somehow I think that can stunt the ability to develop emotionally, because you are so constrained. I'm thinking, did you listen to Brown or see his or read his book about the glass? Was it called The Glass Ceiling? Or not The Glass Ceiling, but he was referring to his homosexuality and how it had greatly influenced him from a young age. And although it was unspoken at the top of the management of BP that it was quite clear that he was gay, it was impossible to allow that to be a natural part of conversation during the time he was in charge. 20 years later, that's now not a problem. That's not one of the big issues of our day. We have other ones instead that have come along. But all the time we are constrained and under these forces from without, which are our societal expectations. And that's within one culture, let alone, you were saying, going around the world and finding 15 different cultures with 15 different societal norms.
Absolutely. And things are different from one culture or one region of the world to the next region. And that's why when I started this soft competency committee for SPE, when I was the SPE president, I said that we have to start finding experts in different parts of the world. So, for example, rules of ethics is not the same as in the United States versus UK versus Indonesia versus Gabon. You know, everybody has their own definitions based on their culture and traditions and habits. Everything about soft competencies, it could be regionally or culturally influenced. So, but one thing is important, that we continue learning soft competencies. And if you note, and this is in my first lecture, that when we're a little kid, what do you hear all the time from your parents? Say hi, share your toys, you know, be nice. So these are all soft competencies that are, you know, our parents try to teach us, to instill with us. And then we come to grade school and then high school, and we forget about all that training. Nobody emphasizes that anymore. Not in college until a few years back, and not extensive enough yet. And then we come to the place of work in a team environment, and we expect to understand and respect diversity, people of different skin colors, different accents, different background and traditions, be able to resolve our conflicts and all that. And it's not easy. So it has been very difficult for some people to get along in the work environment these days. And whatever I said today also is true for family life. When you go back home every evening, you know, you're back in a team, in a different team that is comprised of your spouse and your kids. And you have to manage that. Your spouse manages another part, and you have to be able to resolve conflicts and respect others as well. So everything that I talked about today works as well in a family environment too.
I must ask you, Manushir, since I know that you managed to successfully bridge two really apparently different cultures, why don't you talk about how that process worked within you?
Well, I don't know. I have to think self-analysis, but as you said, it was being more conscious. I did also an MBA course, but not at the beginning. Halfway through, when I was already 5 years of exploration manager for an American company, I took the MBA course to learn these things. But I think before that, it was self-consciousness of being aware, you know, automatically learning it. And I don't know, maybe Middle East and Islamic, I'm not sure Islamic, as you said, not religious. It's the spirituality, the way we were brought up, especially before revolution, we were more spiritual than afterwards. I think that probably in the family, I don't know, Dr. Fattahi says as well, that partly helped as well. I really don't know the answer to your question. As you said, when you're exposed and you have people with different characters, some odd, and you want them to do this contour map or go and sit on this well, you have to write this report and you have to manage them. You have to use your soft competencies, but unconsciously I was doing it at the time. That's all I can tell you.
I think some of that also comes from your parents a long time ago. That still is in your mind and you're bringing up. That be nice to others, be kind, say hi, you know. So all of these make us, some of us at least, a little bit conscious when we get to the work environment. But because we have not been trained formally, some of us think that we own it, we know everything, and I don't need to be trained. And that's the what I call the skilled incompetence. That creates a skilled incompetence, that you practice the thing that you're the only one who thinks it's right, but my God, you're the manager and you're gonna pull the entire team behind you.
Can I say something? I took the MBA course not to learn the soft competency. I learned because I wanted to learn the techniques that these accountants were asking me and financiers. Our job was very simple: company, you know, drilling and so on, get the budget from New York and run the contract, do this, etc. And but they were making us, all the technical team, to answer and fill forms for the accountants, you see, which was, so I wanted to have the challenge, the confidence to challenge and stand in front of the accountants and said, look, my staff, I have to do their work. They have to spend hours and hours filling the form, cash call, this and so every week. That was the reason why I went into MBA.
But you also mentioned you wanted to understand other people. That's soft competency. That's communication.
Yes.
That's also part of it, because you had respect for your accountant, and so you wanted to understand his language.
Yeah.
So
that's true.
This understanding, in your case, it was professional, but in some other cases could be language, gender, other type of things that you learn because you want to respect your coworkers. So, I'm glad that you did it.
Camille, you come on video. Is that because you want to say something?
Yes, exactly.
Brilliant.
So, yeah. So, I mean, first of all, I would say I'm really delighted to be amongst very experienced people like you guys, and I wanted to talk about one thing basically. So, I've been in this situation most of the time. So, when we are working in a team, and then sometimes one of us has to lead, even unconsciously. You don't select a leader, but one of them has to lead. For me, it doesn't come to me naturally that I go ahead and then lead, but sometimes I feel like I am the right one to lead. So, but I don't believe more in the leadership part. I believe more in the teamwork. So I'm more as in a team player than to be a leader. But I'm here asking for say a tip or what will you recommend, or what quality do you think our leadership should possess, so that I can keep that in mind, or I can go ahead and work on that for say my future projects, because I'm still on the ladder to go up. So yeah, it would be nice to hear some from you guys.
Right. I think, and this is one opinion, obviously, just you cannot force yourself as a leader. That's the job of a manager. Follow me. I know where we're going. I know everything, so you follow me and we'll get there. And, but the problem with it is that when we get there, nobody really understands the intricacies or the details. And naturally, they don't own the project or the results. So, if you want to become a leader, first of all, you have to become aware of who is around you. And like Tim mentioned a few minutes ago, that you have to become familiar with your own capabilities. Okay, you have to discover yourself. And then build up on the ones that you're strong and fill the gap that you are not strong in. But if you go, for example, and work in Indonesia, you may need different soft competencies. And if you work in Switzerland, okay? So depending on the environment, you have to, and these are some things that I've talked about in my first lecture, that, I have created a matrix that shows what you need to do. But anyway, I'm referring back to that matrix that I had in the other talk, that you have to find out what is needed in the new environment. And although you may find some of the things that you learned and it's not useful now, but the ones that you feel is a gap for you, try to learn those and practice those. But to me, the most competency skill is understanding diversity. That to me is whether gender diversity or anything. It just absolutely, because the world has become small and we are all together on this planet and we are in constant communication with one another. And we have to understand each other the best we can. And so try to, you don't need to find out the intimate stuff about your coworkers, but know enough that they feel that you care. And once you practice these things, like a dance thing that a dance example that I made, once you start dancing in a nice way, you impress the audience, and the audience feel that you are the leader. You're the one that they want to follow. You're the role model. And that's, you cannot force yourself and say, well, I have a PhD, and so, I need to be the leader. No, that doesn't work.
Yeah.
I noticed that Peter Cameron, you've opened the video. Peter,
yes,
you want to say something?
No, I was just joining in the conversation. And leadership, I think I'm thinking about those, like, people in the Second World War in the Japanese prisoner of war camps. There's one, he became a school teacher or something afterwards, and he was something nondescript before the war, but he was just the right person in the right place, and he took charge of all the soldiers in this particular camp and led them through. I think leadership is very much dependent on the situation, having a job to do. There's no point being a leader and you just say, I'm the leader, and nothing happens. People take over as leadership, the leaders, when there's a job to be done, they say, right, this is what you do. There's no crisis anymore. You do that, and all the rest of it. And that's when leadership comes into its own. Sorry,
Well, Peter, of course, situation is important and circumstances are important. But if you are a fake leader, people find out soon, and people will not follow you or will not adhere to what you expect them. And you may rule for a little while, but it's not going to be long term. So if you want good results and a successful team, you have to become a natural leader. And as I have repeated many, many times, some of it comes from within you, but that is the part that it makes you desire to learn or desire to live with others in peace and respect others and so forth. So you have to go, even with that desire, you have to go and be trained and then practice and practice and practice so you become successful. So in a wartime situation, obviously in the military, there are a lot of leaders, but not all of them have the leadership skills. They're just promoted to that position and they're transferred from one department to another, from one division to another. And it's usually in a military environment, it's more or less by order and discipline and force. It's not a natural selection of leaders. To me, that's my opinion.
I just want to say something to Camille. One thing, if you want to be this leader, I think I learned this 20 years ago. Someone said, you've been given one mouth but two ears. So you become a good listener and then you'll be fine. That's all you have to do. There's obviously a lot of theory, but that's a good start. So like on sustainability, we're having to listening to thousands of people, of which one of them's got a good idea. So it's right. When you're in a step change, you've got to listen to more people. So we don't have 1,000 ears, but we've got one mouth. But
exactly. And listening is an important part of soft competencies, because when you're talking, you're not learning anything. It's only when you listen, and you listen to others and learn from others, and then you digest what you've learned and you pick and select the best and you practice those. So listening is an important part of the important training. I took a 5-day course in listening with Shell when I was a young engineer. So it's important. And you cannot imagine how much stuff went into that course that at the beginning I was pretty skeptical, but it turned out to be one of perhaps the best course I've ever taken.
If you go to my Gaia sustainability website, well, you can see on the SPE, we put 9 skills down there, but only which 3 are actually on performance based. But listening is so key.
So key.
Listening is key, yes, but not necessarily doing anything about it. Yeah, if there's a crisis, it's best to stick to the plan that was worked out beforehand, not listen to all the people panicking and saying different things in the middle of the crisis. At that time, the leader says, "No, this is the plan. You be quiet and just do your bit."
Exactly.
That's a manager.
Yeah, and
That's not the lead. That's not the true leader.
yeah,
That's a manager.
and then also
Manager,
that's a situational based.
Manager creates order, discipline, a goal. I take you from point A to point B, and I've done that hundreds of times, and we're going to get there. But the problem with that along the way, you're not training new leaders. You don't allow other people to grow and exercise the right of leadership. And therefore, at the other end, you got a bunch of unhappy people. You may have achieved your goal, but you have a bunch of unhappy people at the end that they were taken there to point B by force, not by the desire. And along the way, they did not learn anything. They just worked as slaves.
Yeah, I think, wait a minute, I think Peter's picking up a different point, which is in a crisis, like, for example, a life and death situation, then you do need, and to pick up on Camille's point, it becomes situational leadership. And that therefore means that direction is the right way in order to save everybody. Now, it may well be thereafter that you all sit down and say, well, how could I have done that better? But the first thing is you've got to leave the ship that's sinking, or you've got to get away from the enemy fire, or whatever it might be. And that is a different situation.
That I agree.
Yeah.
That I agree with. You remember that the slide that I showed with the brain segments?
Yeah.
With the logic and the limbic?
Yeah.
Well, same person makes a little bit different, more logical or less logical in different situations. So in the case that Peter brought up, you know, your logic may take over and be on the managerial side rather than the leadership side. So that's the beauty of combining the two, that you can move from one to the other or be in the middle someplace, depending on the situations. So, you know, I agree with you, Peter. And, you know, after Tim explained to me what you were trying to tell me, that is, you know, depending on the situation and the amount of time that you have to make a short decision. But that's, you know, what I try to say is just don't make that a habit. Don't feel that, okay, it worked for me in this 2-day situation thing and we got to our goals, but for the next 2 years, I'm going to do the same thing for longer term projects, you know, because your job as a leader is to train other leaders. That's the main thing. And you fail if you cannot train other leaders to replace you eventually.
Can I ask another question about this? So we all hear about alpha males, but there's the sigma male, which is they're capable of leading and being like an alpha male, but they couldn't be bothered. And they step up when they have to from time to time, but most of the time they actually can't be bothered. I find this myself. You know, when there's something to be done, I will take the lead and not let anyone else get in the way. But most of the time, I just leave people alone. Managing them is just too much of an effort. Is there such a type, or have I just made that up?
Well, no. I mean, it's good that I hear from you that you leave people alone, let them grow and let them have their own initiative. In one of my slides, I said bottom-up initiative. And that's the greatest thing, if you can allow that. Sometimes the circumstances of situations, like you mentioned, does not allow enough time for people to grow and try their own or test their own, style. So, but it's good that you leave them alone, let them grow. But
well, it's not
if you
good.
have a,
It's not good. We had a deadline yesterday midday, and I left them for weeks. And the day before the deadline, I said, right, where are we? And it was complete dog's breakfast, or was it dog's breakfast or dinner? It was a complete mess. I was literally working right through the night to get this done in time. That was not good leadership.
No, it wasn't. And then again, I refer you to the slide that I showed, leadership versus, management versus leadership, and which quadrant you want to be in a company or an organization. So you left them alone, you said, for 2 weeks. So what happened to your management style or management skills? You know, you went quite a bit under leadership direction, but you lost your management. Because I said it's a combination of the two. You have to create order and discipline and goals, but at the same time understand people and develop other people to develop as well. So all of these are important, you know, for running a division or a company or the department that you work. So you forgot about your setting disciplines and deadlines, and that is not in conflict with leadership. You can still apply your leadership, but also you have to keep that management trait and attributes a little bit into the game.
We've been talking for an hour and a half.
Yeah,
I'm wondering whether it's probably time to draw this to a close. Is there anything anybody would like to say in concluding remarks, just to summarize, or a tangential remark, something fun, a final thought to leave us with before we say thank you to Behrooz? Any final thoughts?
Positive notes. So do you actually think our industry will survive all the sustainability malarkey? And are we completely screwed because of complete lack of management and leadership, which seems to be happening at the moment? Because clearly we haven't been looking after our missions, and we're in a very bad state. So what you're saying is we haven't got the right managers, and we haven't got the right leaders, and we haven't got the right leadership. So what do you think, what is going to save our industry?
In our industry?
Yeah.
In the oil industry? Well, we're going to actually, in the oil industry, if I understood your question right, is that we're going to a transition now from the oil and gas into renewables at some point. Now, people have different judgments. They say in the next 10 years, some people will say next 50 years, and some people say by the end of the century. So, but we are going through a transition, and this transition is not like a switch that you can shut off or turn on. It has to be gradual, and it has to be in a sustainable way. So here we need leaders to lead us to this complicated path into the future. We know where the goal is at some point, but we need leaders in our industry. And unfortunately, there are some people in our industry that have set their mind that oil and gas will be here forever. And it's true, oil and gas will be here forever, but may not be useful at some point. I mean, we have plenty of oil and gas, maybe 70% of the oil and gas in the world is still underground. So we won't run out of oil and gas, but we will run out of the utility of oil and gas at some point. So we need leaders in our industry to lead us to and to make things happen until we get there. And that doesn't mean that we are going to lose our jobs. Our companies have been and are and will transform into energy companies. And at some point, you know, Shell, for example, is little by little getting out of oil business. They are more taking on the gas and eventually other other forms of energy. Chevron, Exxon and other Total, all these BP, all these companies are spending lots of money on new energies. So at some point, all of us will be working, not me, of course, I'm retired now, but most of you younger people will be working in the new energy era with the training that you have, but you have to find that way alongside the leaders that will lead you in that direction.
Thank you. That was inspiring, uplifting, fascinating, highly educational. I've had a tremendous couple of hours, and I hope the rest of you have as well. So I will bid you adieu, and Behrooz, my heartfelt thanks to you for all you shared with us. It's been an absolute joy and delight to hear your opinions. Thank you, and thank you all of you for staying the course, and it was such great
pleasure. The pleasure was mine. Thank you so much, and it was great seeing all of you.
All right then.
Thank you.
Good night,
Thank
everyone.
you, Behrooz.
Good night.
Bye-bye.
Thank you very much.